Night air thinned over the high desert, and the domes waited like held breath. The sky had the quiet of an ancient archive, pages of starlight stacked beyond counting. In that quiet, a traveler crossed the field of view with the grace of an uninvited thought. It did not shout. It did not tear the heavens. It drew only a subtle veil, a softening of darkness that suggested a coma thin as frost. Somewhere, far outside the geometry of familiar orbits, outside the long negotiations between planets and their snowbound kin, a history had detached itself and arrived. He knew that space is not empty. He knew it behaves like a slow river, a fabric taught by Einstein to curve and lean around mass, a current traced by faint magnetic fields and the breath of suns. In this river, even a pebble announces itself. The pebble now moved across the solar system, and no tide in this system owned it. The motion did not promise a return. It passed like a stranger who will not leave a name at the gate. Dust woke behind it, tender and pale. Grain by grain, it built a soft crown that tried to remember its long, cold sleep. Each mote had spent eons in a night beyond all calendars, and now sunlight stroked it into life. The light did not meet a surface that was smooth. It met a skin weathered by uncounted collisions with atoms of hydrogen, with ions that drift between stars, with the low thunder of radiation that never rests. The wake that formed was not violent. It was a gentle shock wave, a frontier of airless sound, the smallest possible agreement between stellar wind and interstellar residue. The heliosphere felt it, a sigh drawn by a traveler who had crossed an ocean of nothing and everything. He had read about the first unexpected wanderer. He had watched the second flower like a small comet, bright with familiar chemistry. Now a third arrived, and the habit of the mind that seeks patterns flinched. 3 is a number that starts a rhythm. 3 is enough to ask if visitors are not rare accidents, but a subdued migration through the alleys between stars. He did not say this aloud. He listened to the low murmur of fans and the quiet click of tracking mounts, and he let the idea settle like dew on thought. The night permitted a slow attention. The object did not care for drama. It allowed its presence to be detected, as if by courtesy, allowing photons to loosen from sunlit ices and scatter in directions that would include a few centimeters of mirror and glass. The signal rose a little above noise and held there. Patience could coax a shape from it. Patience could separate this traveler from the local tribe of comets that nap in the Oort cloud and occasionally come home to the warmth that unbinds them. He pictured the birthplace. Not a specific star, not a particular morning in the forge of a protoplanetary disk, but a condition. A cradle broad enough to spin 1,000 icy bodies. A neighborhood crowded with infant worlds that pulled and jostled like ships leaving port in fog. In that early confusion, gravity plays a harsh music. Some objects marry a planet and become moons. Some surrender to a stable orbit and age in familiar cold. Some feel a chance touch at just the unlucky angle, and their parabolas loosen into escape. The traveler before him had likely been exiled by such a touch. The exile would have been silent. There is no sound where it happened. There is only the persistent arithmetic of motion. Once exiled, it joined the slow drift between stars, a citizen of nowhere, a voyager that would not age in any calendar, that would not belong to any warmth. He thought of Hawking, and the insistence that the universe has a horizon for every vantage point, that every boundary is a lesson in how little can be known with certainty. The traveler carried that lesson in its faint blur. The sky moved a little. Earth rolled, and the domes corrected for the roll. Sensors cooled and became more attentive. The traveler turned slightly, revealing that its light was not constant, as if its body were not uniform, as if shadow and sun braided each other across a surface of pits and fissures. It looked bruised. It looked like an old seed that kept a code within, a private summary of pressure and chemistry and temperature from a time when its home star still wore a disk of dust. He did not think of capture. The path would not bend into loyalty. He thought of encounter. Encounters leave traces. They tilt instruments into new calibrations. They force better questions. On the screens, the object brightened almost imperceptibly. A coma grew by degrees the eye could not appreciate, but software could. Numbers gathering on the right side of the interface acquired a patience of their own. There is a poetry in small numbers when they gather. a change of less than a tenth of a magnitude that whispers of vapor working its way through pores, of sunlight winning a narrow argument against cohesion. A breeze the size of a star streamed past, the solar wind working its continuous will. Where it met the breath of the traveller, it formed an invisible cusp, a boundary thin as a thought. The boundary did not ring like a bell. It folded softly. It turned the wind into a shawl. To name this gentle shockwave is to admit that even absence has structure. The universe does not allow two fluids to meet without form. Even when those fluids are near vacuum, even when the abundance of particles would fit on a fingertip, the meeting writes a line, and the line drifts with the wanderer as it carves its brief lane through the heliosphere. He understood that this was a moment when imagination must be cautious. Romance is easy at a telescope. Hypothesis must hold still and let data speak. Yet the imagination is a tool too, and it tried out ideas the way a musician touches a theme to hear if it resonates. He asked himself what it meant for a civilization to live in a cosmos where such travelers pass without warning. He asked what a world might learn by catching the faint perfumes that such a body lets go as it warms. He pictured spectrographs dividing the light into orderly bands, a barcode for alien ice. He pictured curves the color of ghostly rainbows. In those curves would be clues to distance, to childhood weather, to the way carbon and nitrogen married in a different nursery. The dome hummed, a soft mechanical heartbeat. The comet, if that was the right word, drifted. He chose to think of it as a witness. It had seen no landscapes. It had known no sun that lingered for long. But it had endured. Endurance leaves marks that can be read by careful hands. If the coma and dust could be weighed in light, if the light could be weighed in models, if the models could be weighed against the observation and not found wanting, then the witness might speak. Stars swing slowly. Galaxies decorate the edges of vision. The horizon feels near in such rooms, but he kept thinking outward, past the woven layers of magnetized plasma, past the soft bow that wrapped itself around the traveler, into the dusky spaces where the distances become so large that the mind needs metaphors just to stand upright. The traveler was small, but small things can carry the voice of large processes. A single grain of stony dust from a meteor can preserve the isotope signature of a dying star. A faint comet can preserve the weather of an early disk. A modest interstellar visitor can preserve the crisis of a young planetary system that learned to rid itself of debris so that planets might grow in peace. This was the quiet at the start of a conversation. The sky did not change its color. The stars did not blink appreciably. Yet a presence had stepped into the room of our attention, and with it came the awareness that the solar system is not a closed book. It is a page among pages. Occasionally, a corner of another page curls across the margin, and a reader who is willing to lean in can read a single borrowed sentence. The sentence is brief, but it carries the shape of the larger story. There is humility in that, and there is exhilaration. Far from any microphone, the universe whispers at volumes that only careful tools can hear. The whisper that arrived tonight carried a life lived at nearly absolute zero, a journey through pale starlight, a patience beyond any season. It did not ask to be found. Discovery is not a favor. It is the outcome of attention. The attention had been sharpened by earlier surprises, and now it found itself rewarded again, not by spectacle, but by delicacy. The reward was a presence that bent no orbit into family, that promised no long return, that accepted our glance and moved on. A gentle shockwave followed, a soft border that marked the meeting of winds. In that border, science could listen, and listening would be enough, at least for now. On a southern winter night in the Coquimbo Highlands, a half-meter survey telescope searched a crowded strip of sky near the Milky Way's spine. The instrument belonged to a watchful network, with a practical name and a vigilant purpose, scanning for anything that might one day trouble Earth. Its camera did not look for spectacle. It looked for change. 4 exposures, spaced by minutes, found a speck that refused to behave like the star field behind it. Software measured the speck's shift against the fixed pattern and stitched the dots into a tracklet. Numbers appeared with the calm of a heartbeat. The observatory at Rio Hurtado, Chile, had seen something that moved with intention. NASA science. The tracklet did not travel alone. Across the world, sibling telescopes of the same survey had also recorded the same speck without yet knowing its name. Archives were opened, and pre-discovery frames showed the wanderer days earlier, dimmer, farther, already on approach. Another machine in California, designed to trawl the night for anything transient, revealed supporting markings of the same faint traveler. A timeline took shape, like footprints back to the door. The pattern told a quiet story of patient arrival, recognized only when enough points had been laid down to hear the rhythm. NASA Science. The news left the hilltop and entered a human web tuned for such murmurs. Coordinates and times were sent to the clearinghouse that listens for the solar system's shifting population. The report carried the signature of a survey tasked with warning, but equally adept at wonder. In the ledger of first sightings, it was marked with a day and a code. Chile's station contributed the crucial sequence. A date fixed itself to the event, the 1st of July 2025, the moment the detection earned a place in the official record. MinorPlanetCenter.net. Who saw it can be answered in two ways. There were the names of the people who built and shepherded the instruments, who tuned algorithms and trained them to catch a moving point against a storm of stars. There were also the names that stand for collective craft, the survey's acronym, the university that houses it, the funding that keeps it vigilant. Together they formed a discipline that can harvest a signal only a few dozen photons above the noise. The Chilean mountaintop provided the sky, the telescope supplied the eye, and the software offered a first cautious whisper: object inbound, magnitude faint, motion real. MinorPlanetCenter.net. JIE. Location matters in discovery. The southern instrument looked along a dense galactic backdrop where confusion is easy, where every fraction of a pixel must be argued into certainty. Yet advantage hides in such difficulty. The field is rich, the cadence relentless, and a telescope that can find a dim moving dot there can find one anywhere. The altitude brought dry, steady air. The winter season stretched long nights like blank film. Above that landscape, the small mirror gathered light that had left a cold surface hours before, skimming the inner realm of giant planets on a steep, unbound trajectory. Astroblob.com. JIE. How it was recognized lies in the craft of astrometry. A piece of code subtracts one image from another, and what remains is change. Cosmic rays, detector blemishes, satellite streaks, and the occasional restless atmosphere all try to impersonate discovery. Filters reject the liars. The object stayed. More frames followed. The moving point maintained coherence across time and across instruments. When all the measurements were linked, a preliminary orbit dropped out of the equations like a key falling into a ready hand. The conic was not closed. The speed was too high for loyalty to the Sunday. The curve declared origin beyond the family of local comets. NASA Science. Within hours, the clearinghouse issued an announcement. A provisional label entered the stream, then a cometary name that folded the survey into the story. The designation carried two truths at once. It stated that activity had been seen, a thin coma bright enough to remove any doubt about volatile ices. It also stated that the object was the third of its kind ever found crossing the inner provinces of the Sun's domain. The letter that signifies interstellar travel was set before the name with the calm certainty of an archivist's stamp. MinorPlanetCenter.net. JIE. Confirmation depends on more than a single observatory. Telescopes in both hemispheres turned toward the intruder. With each new measure, the orbit refined, uncertainties shrinking like frost under morning light. Recovery points extended the arc into the preceding weeks. The longer arc hardened the verdict. The numbers would not yield a bound solution. The visitor traced a hyperbola that had been falling toward the sun for ages, unseen until machines and methods matured enough to notice. NASA Science. The instrument that first raised the alert was built for vigilance, an early warning system with a humane irony in its purpose. It looks for danger and finds meaning. Its nightly routine is a discipline of patience. Each field is imaged again and again. Each subtraction breeds candidates. Each candidate is assigned a probability and a request for follow-up. Humans watch the stream to ensure that no rare thing drowns there. Discovery in this context is an orchestration of automation and attention, a duet of silicon and insight. The Chilean station provided the first notes of that duet for this traveler. NASA Science. News outlets wrote the story in a language of speed and distance, translating kilometers per second into images of motion that could be felt. Yet the facts retained a restrained beauty. The detection was faint. The path came from the general direction of Sagittarius, where the night is busy with old light. The reported closest pass to Earth would be indifferent, no threat and no spectacle, a safe glide through the interior system. The day of closest approach to the Sun was still ahead when the discovery was filed. Those who build calendars for comets marked the date and prepared instruments to listen harder as the ices warmed. Reuters. Jai. Names give shape to attention. The survey's name became part of the comets, a quiet honor that recognizes method as much as luck. The third mark in the interstellar ledger established a lineage that had seemed lonely for years. First came a shard that refused to grow a coma. Then came a small comet that behaved in familiar ways while keeping its passport from elsewhere. This new one arrived with both activity and speed, bearing a chemistry to be resolved and a nucleus to be sized by long exposure and careful modeling. The registry number made the novelty ordinary enough to study. NASA Science. The first official image that accompanied the discovery notice had the aesthetic of proof. A star field crowded the frame. Crosshairs marked a single point that had changed its address between exposures. To the untrained eye, it was a grain in a storm. To the trained eye, it was an arrow drawn with minimal ink. The caption gave the date and the place and the reason to care. It was not a photograph of drama. It was evidence. Evidence is the native poetry of science, a cadence of coordinates and times that anyone may verify. NASA Science. The question of who discovered the object resolves into a chain. Engineers made a sensitive camera and placed it under a dark sky. Observers kept the cadence true in weather that can change from hour to hour. Analysts tuned grades for candidate tracks so that false alarms would be rare but real alarms would not be lost. Archivists maintained a flow of images so that, when asked, the past could be searched for the same moving dot. Coordinators sent the packet to the node that watches over small worlds. Each link held. Each link deserves the verb to discover. MinorPlanetCenter.net. The place of discovery is a page in a larger atlas. A saddle of land in the Andes offers the steadiness required for millimagnitude measurements and sub-arcsecond positions. The night there is cold and intimate with the sky. The telescope is modest by the standards of giant mirrors that carve galaxies out of blackness. Yet modest instruments that work every clear night will sometimes bring home the rarest prey. Reliability is a type of vision. The network's rhythm ensured that a speck on one night could become a path by morning. Astroblob.com. How it entered public knowing is simple and intricate at once. A measured drift became an orbit. An orbit became a classification. The classification became an invitation. Spacecraft teams planned glances from other worlds. Large telescopes cued exposure time. Spectrographs prepared to split the smallest glow. The discovery had already done its essential work by then. It had told the species that the night sky is not only a stage for its own familiar debris, it is also a doorway that opens without announcement, through which messengers arrive bearing the weather of other births. NASA Science. Equations gathered like migrating birds, each one holding a direction. The first positions were small inscriptions on the celestial sphere, right ascensions and declinations marked with the modesty of hundredths of an arcsecond. From those marks, velocities emerged. The sky does not grant velocity directly. It offers changes in angle and invites inference. Observers answered with the patient geometry of parallax, with careful timing that lets motion be separated from Earth's own turning. When the slope of the track was finally clear, a quiet verdict began to take shape inside the numbers. The verdict concerned binding. Binding means that the sun's gravity keeps a body as a lifelong partner, however elongated or inclined the path may be. To test for binding, the calculation shifts frames from the heliocentric view that treats the sun as a pole star to the barycentric view that listens to the system's center of mass. In that frame, the concrete measure is eccentricity. A curve with eccentricity less than 1 is an ellipse, a promise of return. A curve with eccentricity equal to 1 is a parabola, the borderland between loyalty and escape. Past that line, the curve becomes a hyperbola, and the promise is broken. The emerging orbit fell on the far side of the border. With more measurements, the error bars retreated. Each new night added a bead of certainty to the chain. When a model's residuals shrink and refuse to wander, theory tightens into knowledge. The speed at large distance from the Sun, the excess velocity that would remain even out in the slow reaches where the solar wind grows thin, refused to vanish. It held a finite value, the signature of origin beyond the Sun's long reach. The number did not need to be dramatic. It only needed to be indifferent to capture. Indifference was exactly what the fit required. A skeptic inside the analysis tested other paths. Could a quiet push from outgassing fake such freedom, turning a parabolic curve into one that only looked hyperbolic because sunlight was acting as a hidden thruster? The data argued against that rescue. The accelerations that come from venting ices leave fingerprints. They nudge a nucleus in ways that align with jets and rotation, tilting the track subtly as the object warms. The FITs tried versions that allowed such effects and asked them to explain the excess speed. They could not. The unbound answer remained the simplest explanation that respected the measurements. Backward integration added another layer of testing. This is a method that asks the orbit to walk uphill against time through a forest of planetary gravities and back into quieter space. If the path had been a local body in disguise, shaken loose by a violent planetary encounter in the recent past, the integration would have found a near miss with a giant world, a slingshot close enough to impart escape. The rewind found no such past intimacy. The track threaded the inner system cleanly, and in the regions near the big planets it stayed too distant to steal enough energy for exile. The energy was already present when the object crossed the heliopause into the Sun's domain. The numbers were not content with a simple label. They sought texture. Inclination speaks of the tilt against the ecliptic, the slow table where most planets dine. A steep tilt tells of an origin not concerned with the plane of local dust. The tilt here was severe, the path diving through the familiar system on a line that barely acknowledged the layout of the planets. Perihelion distance, the size of the closest brush with the Sun, carried its own meaning. Too near, and heating would erase subtle clues through violent outgassing. Too far, and the faint coma might never quite lift. The distance settled into a bracket that favored observation without chaos. At this point, the orbit was no longer a sketch. It was a map. The map could be used to predict hours and angles for telescopes across the world. Predictability confirmed origin. Bound comets can surprise their watchers with sudden brightness changes that confuse centers and fake positions. This traveler stayed obedient to the path that the mathematics assigned. The chromatic glow might flare or fade with solar weather, but the center of mass kept the appointment that gravity made for it. A different kind of certainty arrived from coordinate transformations. The vector of motion, when translated from the language of ecliptic longitude and latitude into the galaxy's frame, pointed outward from no nearby stellar system. It traced a line that did not betray a recent departure from any bright neighboring Sunday. It looked the way an old drift looks, established long before it wandered into the realm of planets. The solar system, for all its mass and history, was an incidental stage along the way. Small corrections continued to polish the path. Radiation pressure, the subtle push of sunlight on dust and gas, was included. So were the higher-order terms that account for the Sun's movement inside the galaxy and the gentle tidal slopes sculpted by distant mass. None of it softened the conclusion. If anything, the refinement strengthened the idea that the orbit's eccentricity was not a fragile artifact of early uncertainty. It was a robust fact that persisted across models and assumptions. The language of escape can mislead by invoking drama where none is needed. There was no sharp departure. There was only a free fall through a gravitational field that could not bend the trajectory into an embrace. The analytic form of that fall carries a simple beauty. The hyperbola has an asymptote, a direction of approach in the distant past, and a direction of departure in the distant future. Those lines can be extended across light years in the mind's eye. They serve as memory and prophecy for a body that itself has neither. That geometry is the quiet kernel of the unbound truth. Comparisons with the known populations added context. Long-period comets from distant reservoirs can carry eccentricities that graze unity closely. Their uncertainty ellipses often straddle the border between bound and unbound, until long arcs of observation clarify the status. This case did not cling to the boundary. The distance between its fitted eccentricity and the critical value remained comfortably wide, even as errors shrank. The path refused the company of local tribes. Time feeds orbits. As weeks passed, the lengthened arc allowed computation of a barycentric state vector that could be propagated well beyond the planetary region, without fear of numerical tricks. The outbound speed in that quiet model mellowed only slightly from the value near the Sun, as expected when the dominant force has been left behind. It forecast a future in which the visitor recedes into interstellar dusk, retaining a measurable heartbeat of motion forever. Observational subtlety met dynamical certainty in the analysis of light curve. The nucleus rotated, and the flux rose and fell accordingly. Rotation can pull orbits off course when jets behave like thrusters attached to a spinning body. This twist can masquerade as exotic dynamics if left unmodeled. Adding it did not save the hope of binding. The directional changes caused by rotation-driven outgassing remained orthogonal to the fundamental freedom embedded in the speed. The hyperbola ignored the spin. In seminars and quiet rooms, the meaning of unbound was phrased in unromantic terms. Incoming radiant, excess velocity, three-dimensional orientation with respect to the local standard of rest, covariance matrices that behave well under transformation. The technical prose concealed a modest astonishment. It is not common to witness a messenger whose story is written in a grammar older than any local dialect of orbits. The messenger spoke fluently in that older language. One more test waited, the kind that respects how the solar system's gravity field is not a point source but a chorus. Planetary perturbations can deform fresh orbits more than late analyses expect. Teams independent of one another integrated the trajectory using different numerical schemes, different ephemerides, and different tolerances for truncation error. Their results agreed within the noise expected for such calculations. Agreement across methods is the mathematician's smile, a small confirmation that confidence is not a solo performance. By the time the path was declared with formal phrasing, the conclusion felt almost quiet. The trajectory belonged to no gravitational household in this neighborhood. The object had arrived carrying energy that the Sun could not absorb. It would leave carrying nearly the same. Its unbound nature was not a flourish. It was an accounting result, a ledger that refused creative interpretation. The sky tolerates poetry, but it pays its debts in hard numbers. Here the numbers had spoken with rare clarity, and their message was simple. The traveler would not be ours to keep. Sunlight touched frozen cliffs and a breath began. Molecules unlatched from grains that had been compacted by a silence measured in eons. At first the escape seemed private, a vapor curling across shadowed hollows and easing into black. Then the space around the nucleus filled with a cloud of neutrals, an invisible orchard suspended in slow expansion. The cloud grew, until the wind from the star arrived to negotiate a boundary. Where that wind met the new atmosphere, a frontier formed. It did not crackle like a storm. It arranged itself with restrained ceremony, a gentle shockwave composed of particles and fields that recognized each other without sound. In that terrain, the rules are set by speed and rarity. The solar wind rushes outward at hundreds of kilometers per second, carrying a magnetic field folded into spirals by rotation. The coma expands at only a fraction of that pace, carried by the thermal motions of water, carbon monoxide, carbon dioxide, and a suite of minor species awakened from glassy prisons. Collisions between gas molecules are scarce beyond the inner few hundred kilometers, so chemistry and dynamics separate into different theaters. Photons from the star cleave molecules, peel off electrons, and sculpt a plasma from the neutral cloud. Ionization timescales of minutes and hours compete with expansion timescales of seconds and minutes, and the balance writes the size of the regions around the nucleus. Once ions appear, the conversation with the wind changes. Newly charged molecules feel the interplanetary magnetic field as a force that turns free drift into gyromotion. They are born nearly at rest, and are suddenly thrown into circular arcs around field lines that sweep past. This abrupt change creates ring beam distributions that cannot last quietly. Instabilities wake and launch low-frequency waves into the medium. The waves grow and feed on the newborn ions, and the growth acts like friction without contact, bleeding energy from the solar wind into the developing plasma environment. The wind notices. Its flow lines bend around the expanding obstacle. Field lines drape, laying themselves along the flanks of the coma like ribbons that refuse to cut through the dense center. Ahead of the nucleus, where the confrontation is head-on, the flow slows and warms. In many comets, this region hosts a bow wave rather than a classic collisional shock. Yet even without true collisions, a transition can appear that functions as a shock in spirit. Velocity drops, temperatures climb, and magnetic field strength rises. The change is not violent, it is deliberate. Particles trade order for disorder through collective behavior, and the exchange creates the soft hull of the gentle shock wave. Within the draped field, there is a boundary where the cometary plasma begins to dominate. It is called by various names in different eras of study, but its character is constant. Here, the density of ions born from the coma surpasses that of the solar wind, and the magnetic field piles up because it cannot freely convect through the heavy plume. Downstream of this pile-up, another separation reveals itself. Neutral molecules continue to stream outward through everything else, unconscious of charges and fields, while the charged components are confined and guided. The result is a layered structure. A neutral envelope that is huge and light, an ionized mantle that is smaller and muscular, and a magnetic corset that tightens where the flow slows. Threads of dust complicate the scene with their own laws. Tiny grains escape with the gas, while larger grains lag and describe arcs that sunlight and gravity co-author. Radiation pressure shoves the smallest particles into streams that curve away from the star, and their trajectories can be read like handwriting to infer the size distribution of the dust. Each grain acts as a tiny witness to forces that share no common scale. Micrometer specks report the push of photons. Millimeter clots report the grip of inertia. In aggregate, they paint a tale that looks like intention, even though it is the sum of simple nudges. Photons and ions combine to leave signatures far from visible wavelengths. Charge exchange between heavy solar wind ions and the neutral gas generates soft X-rays that flicker over the coma like a faint ghost of aurora. The same exchanges create fast, neutral atoms that sprint away without the burden of charge, carrying a hidden map of the region's electric fields. Ultraviolet lines brighten in collars around the nucleus as water splits into hydrogen and oxygen, the hydrogen scattering the Lyman alpha light so efficiently that the coma grows to planetary scales in that band. The gentle shock wave, though silent, becomes articulate in these frequencies, each channel telling a slightly different version of the same border crossing. Models step in to discipline intuition. The simplest, born in an era of pencil and paper, treats the neutral flow as a spherically symmetric fountain with sources and sinks. More modern treatments allow jets that drill through the coma, anisotropies that rotate with the body, and chemistry that evolves with distance. The plasma response rides on top of these flows, and its equations are solved with magnetohydrodynamics, where density is high, or with hybrid and kinetic methods, where particles must keep their individuality. All the models agree on one respect. A threshold exists where an expanding comet becomes a real obstacle to the wind. The threshold depends on gas production rate, heliocentric distance, and the changing moods of solar activity. Cross it, and the frontier forms with layered grace. Geometry matters. The nucleus does not shrug off its skin uniformly. Sunlit cliffs vent more, shadows vent less. Rotation tests the stiffness of the draped magnetic field by swinging jets across it, modulating the ionization fountain in a rhythm that instruments can count. The frontier breathes with that rhythm. It brightens and retreats, thickens and thins, as if alive. Yet its vitality has no intention. It is a machine that reacts to supply, to light, and to wind. A tail of ions stretches antisolar, thin and taut. Field lines guide it, so it kinks when the magnetic field shifts. Disconnections can propagate along it, like a violin string suddenly detuned by a twist of the peg. When the sun flings a coronal mass ejection outward, the front of that hot cloud can crash into the cometary boundary and press it inward, sometimes folding the tail until it snaps and rebuilds. The gentle shock wave records such weather as temporary scars, then heals. Close to the body, The gas is dense enough for collisions to resettle energy and for chemistry to shape a microatmosphere. Sublimating ices carry with them trace organics that break apart and rearrange under light. The first few hundred kilometers act as a laboratory in which hydrocarbons, nitriles, and oxygen-bearing molecules participate in a branching network of reactions. Farther out, destiny simplifies again. Ionization selects which atoms and molecules must respond to fields. Neutrals keep flying outward into cold, becoming a fog that thins without ever truly ending. Velocity relative to the sun gives this frontier a distinct character. A faster traveler sees the wind as a harder oncoming stream. The effective Mach number rises, and a sharper bow region can form even at modest gas production rates. Yet, sharp is a relative term in near vacuum. The gradients stretch across lengths so large that the mind must scale up its intuition. What would be the thickness of a wall in air becomes the span of a continent in plasma. Instruments that study the domain rely on integration, accumulating faint photons over long exposures, or building spectra from scattered light that has traveled through millions of kilometers of gentle change. The spectacle is not in brightness, it is in coherence. All the invisible motions arrange themselves around a nucleus barely large enough to be imagined clearly at human distances. The frontier becomes a lantern for physics that is otherwise learned from equations on paper. It validates the idea that shocks can exist without collisions, that magnetic draping can herd charged matter without touching it, that waves launched by newborn ions can tame a wind from a star. The gentleness is an illusion of scale. Power moves through the system as surely as a river through floodplain. Only the river is dilute beyond everyday language. This entire scene carries consequences for what can be read from light. The shape of the frontier affects how much dust remains near the nucleus, how quickly molecules escape without further processing, and how jet directions translate into coma morphology. Spectra must be interpreted with the frontier in mind, because line ratios depend on the balance between photodissociation, ionization, and transport through regions of changing field strength. Even the simplest measurement, brightness as a function of distance from the center, bears the imprint of the boundary's breathing. A visitor that creates such a frontier becomes a brief classroom for the heliosphere itself. The wind that presses on the coma is the same wind that inflates the bubble protecting the planets from most of the galaxy's charged weather. By watching the gentle shockwave settle and rearrange under solar gusts, one learns about the temper of that wind on scales too small for spacecraft to sample everywhere. In this way, a small, cold object writes a gloss on the sun's larger biography, and the frontier it carries across space turns emptiness into structure for as long as the breath lasts. A name is a small harbor for a large unknown. In the language of skywatchers, naming begins with a tally of moments. Coordinates mark the first sight, times stamp the second and the third, and from those points a path is teased out with numbers that carry the weight of certainty. The path is checked, and only then does a sequence of letters and digits arrive to fold the object into a human ledger. The ritual is administrative on its surface. Beneath it lies an act of quiet courage, because to inscribe a symbol is to admit that the unknown will be pursued until it speaks. At first, the newcomer is a coded whisper. The clearinghouse that hears these whispers assigns a provisional tag that means only this: an object moved against the stars with a motion that matches neither satellite nor airplane nor glitch. Observers respond with follow-up. The code gathers companions that record who looked and when. Within that fold of numbers, the early personality emerges. It brightens at a rate that hints at ice. It holds a smear that hints at a coma. The odds tilt toward comet, not rock. A line is drawn under the tally, and a designation with a letter that signals activity begins to form. Interstellar status adds a second grammar. Local comets earn letters that speak of year and sequence. Rare travelers from beyond receive the letter that means interstellar. That mark is a gate. It is not opened lightly. Orbits are sensitive to the smallest errors at this stage, and freedom from the sun must be proven through a discipline that looks for every excuse to keep the object as kin. When the excuses collapse, the letter becomes unavoidable. A digit prefixes the letter to count the lineage of such wanderers. The count remains small, so each new digit feels like a declaration that the solar system is not alone in its traffic. The new name becomes 3i with a partner that honors discovery. Surveys carry names that fold science into community. The chosen partner in this case is a vigilant set of telescopes that search the sky for danger and drift alike. The survey watches night after night and submits a stream of candidates to a world of colleagues. When one of its candidates passes every test and reveals a path from beyond, its name is attached in recognition that vigilance is a form of insight. Thus, the full name pairs the count of interstellar visitors with the working title of the eyes that first noticed the speck. A name like 3i seems spare to anyone who listens for poetry. In practice, its spareness is power. The name organizes effort. It becomes the key word in proposals, the flag in data archives, the label in plots. It ties a family of observations to a single thread so that a photometric curve in one hemisphere and a spectrum in another can be braided without confusion. Funding panels hear the syllables and recognize a priority. Telescope cues adjust with a bias toward rare opportunities. Even silence in the data must be filed under the same banner, because an upper limit on brightness is as honest a witness as a robust detection. The tail of the name carries the survey's soul. Atlas reads like a promise. It implies coverage of the whole sky, a map redrawn each night as if motion were a tide that must be measured to protect a coast. The name also carries the memory of humans who built systems that work while most of the world sleeps. The letter string is therefore not just a credit line. It is a shorthand for a method that democratizes discovery by making the night a public space for many hands and many machines. When a comet bears such a name, it implies that the frontier of knowledge is held open by an alliance of patience and software. Once the name hardens, language around the object settles into formality. Papers begin to adopt a similar cadence. The designation appears in titles. The first lines of abstracts follow the same pattern of discovery date, observing circumstances, and initial properties. That formal music brings stability. It ensures that a reader in any country, opening any journal, can find the trace of the object without wandering through a forest of nicknames. A name can feel like a cage when it limits imagination. Here it is scaffolding. It allows the structure of knowledge to rise without collapsing under its own weight. The arithmetic inside the name can shape expectation. The number 3 implies pattern. 1 is a singularity that might be accident. 2 is an echo that may still fool the ear. 3 is the start of rhythm. With 3, the mind hears cadence and asks for dynamics. How often should such visitors appear? How bright should they be on average? How likely are they to be cometary rather than asteroidal? The number in the name turns those questions from speculation into forecast. Models of ejection from young planetary systems face a slightly sterner test. Detectors of future arrivals can design cadence with a clearer sense of yield. In the lore of comets, names have always been little stories. Some preserve the discoverer's surname. Some honor the observatory that stood in the frost to collect the first unstable light. Interstellar visitors complicate that lore. They must carry a label that marks them as citizens of a larger river. The letter I becomes a gentle insistence that the solar system is not a closed economy. This insistence feeds a philosophical hunger. It becomes easier to imagine a galaxy that shares material, a society of stars where each household inherits traces of neighbors, a slow diffusion that makes the spaces between suns less empty in meaning. There is also a caution inside the label. To call a visitor interstellar is to admit that memory will be brief. Observers know that the arc of visibility will narrow as the geometry changes. The discipline must move quickly, but without haste. A name aids that movement by acting as a beacon that consolidates attention. The beacon does not choose the questions. It simply holds the place where answers will be sorted. Spectra of volatile bands, limits on nucleus size, rotation periods, dust distributions, all of them ride in under the same flag and are archived accordingly. Names have legal weight inside the culture of astronomy. They determine how searches are indexed, how ephemerides are retrieved, how alerts are propagated. In this sense, the name 3i with its partner is not a muse but a key. It unlocks the service that tells a telescope where to look tonight. It unlocks the numerical state that a spacecraft uses to plan a glance. It unlocks the scripting that amateur observers call upon to aim modest optics at a target too faint for the naked eye. Keys are not romantic. They are necessary. They turn complexity into access. Beyond the work of instruments, a name chisels itself into public memory. A debate begins among storytellers about whether to keep the clean line of the official designation or to add a word that sings. The earlier visitors were given a Hawaiian name and a family name in the traditional comet style. The current pattern stays close to function, as if to remind everyone that the romance will come from the physics rather than from the syllables. The phrase, interstellar visitor, is itself a mild chant that carries enough awe to satisfy the ear. Critics of formal naming sometimes argue that a code can domesticate mystery. In the case of an object like this, the domestication is harmless. The mystery is not dimmed by typography. It survives any cage that letters can make. It even benefits from that cage, because shared language prevents chaos. When observers in radio bands write to colleagues in optical bands, and when modelers ask both groups for inputs, the efficiency saved by a crisp name becomes time returned to thinking. Time matters, because faint things fade and low production rates slip under thresholds of detection, while committees are still assembling their agendas. In private moments, those who set the letters in place acknowledge that their craft is ceremonial as well as practical. To write 3Y is to join the century in a simple count that may someday reach into dozens. It is to stand at an early stair and imagine the staircase. The mind that writes the name allows a line of future numerals to extend in thought, each one tied to a night when a tiny glow crossed a field of view and reset expectations. Naming is an admission that continuity exists, that the next arrival will inherit not only a format but a set of improved tools and a deeper patience. A final truth rests inside the pairing of the numeral and the survey. The work belongs to a community. Patrons kept the domes in good repair. Engineers taught silicon to see what human eyes cannot. Students wrote code that sorts candidates in the dark. Seniors taught rigor that resists beautiful but premature conclusions. The string 3I with its partner is a compact acknowledgement of all these labors. It tells anyone who reads it that a civilization invested enough to know when a small visitor from a far cradle passes through its neighborhood. The name is spoken aloud in control rooms and whispered across phone calls that coordinate observing time. It is typed into proposals and printed in the headers of images. For a while, it lives everywhere that attention lives. Then the visitor recedes, and the syllables rest in archives until they are called up by new questions. The letters do not age. They wait as patiently as the object once waited in cold space. In the interim, the community keeps the habit of naming alive, ready for the moment when the next moving point asks for a harbor in language and a place in the affirmed order of things. Light arrived in slivers and confessed to being many things at once. Through a slit carved into the night, it spilled into prisms and gratings, and divided itself into an orderly staircase of wavelengths. Each step held a secret that chemistry cannot help revealing when photons lean upon it. The spectrum became a postcard from a cold childhood, inked not with ink but with bands and lines that remembered where the nucleus was made and how it was kept. Near the ultraviolet, a shy glow at 308 nanometers told of OH. That band is a child of water, born when sunlight breaks the molecule and leaves the fragment to fluoresce in a thin fog around the nucleus. Its brightness rose and fell with heliocentric distance, and the measured G factor allowed the production rate of water to be inferred, even when no particle ever touched a sensor. A little farther to the red, permitted lines of atomic oxygen at 777 and 844 nanometers whispered of parent molecules and lifetimes, while the forbidden green pair at 557.7 and the red doublet at 630 and 636.4 nanometers traced the rest of the family tree. These lines are awkward in air and beautiful in vacuum. Their relative strength sketched where the molecules were broken and how quickly the fragments were quenched by collisions close to the heart of the coma. In the violet, a set of bands brightened like lamp wicks. CN spoke clearly, its resonance fluorescence modulated by the velocity of the source with respect to the sun, a sensitivity known in quiet corridors as the swings effect. The shape of the CN band carried the imprint of expansion and rotation, as if the nucleus had signed its letter by turning the pen in a small arc. The C2 swan bands came greenward, a ragged comb of emission that belongs to fragments cooked from organics. Their intensities, when set against CN, framed the long-standing taxonomy that separates comets rich in carbon chains from those that are depleted. The classification mattered because it is not weather. It is heritage. Infrared windows opened wider secrets. At 3 and 4 micrometers, the fundamental stretches of H2O, CO2, and organics climbed out of the continuum. Spectrographs that drink heat rather than light teased out the ratio of carbon dioxide to water and the relative strength of carbon monoxide. Those ratios fixed the thermometer of formation. A coma with prominent CO near the sun suggested that the ices had been laid down in shadowed cold where carbon monoxide could hide without boiling away. A coma with modest CO and energetic CO2 implied a nursery that allowed some warmth or later processing by cosmic rays and slow diffusion. Boltzmann plots of rotational lines within each band revealed rotational temperatures that were not temperatures in the human sense, but clear signposts of density and distance from the nucleus. Farther still in the infrared, dust became eloquent. The thermal continuum rose with a slope that said how large the grains were and how efficiently they emitted. On top of that continuum, 2 humps at 10 and 18 micrometers betrayed silicates. Their shapes spoke of mineralogy that volcanologists would recognize if rock could be read in light. Crystalline olivine and pyroxene left sharper shoulders, while amorphous counterparts made broader, gentler features. The balance between those states recalled whether the dust had ever been warmed enough to anneal. In a visitor spent in deep freeze, a surplus of amorphous character would not surprise. Yet the smallest surprise would have been no surprise at all, because disks are complicated forges, and exiled bodies can preserve both the furnace and the frost in a single handful of grains. Back in the visible, a sodium pair at 589 nanometers traced a tale of its own. Sodium is fast and fickle in sunshine. Atoms knocked loose from grains or ices can be accelerated by radiation pressure into a filament that the eye might miss, but a spectrograph cannot ignore. The resonance doublet brightened and dimmed with a cadence set by the supply of fresh surface. When the line profiles tilted slightly, they recorded the push of the sun on atoms with hardly any mass at all. Few laboratories on Earth can reproduce such a pressure on a gas. The cometry spectrum makes the laboratory unnecessary. Radio telescopes listened beyond sight and added weight to the ink. Lines of HCN at 88.6 GHz and H2CO and CH3OH nearer and farther gave concrete access to isotope ratios. The balance between 12C and 13C, between 14 newtons and 15 newtons, between the light and heavy flavors of oxygen, wrote a chronology in which chemistry remembers the temperature and density of its youth. Deuterium in water told the strongest story. The D to H ratio came burdened with meaning about distant cold, and the possibility that the visitor carried an archive of an exoplanetary ocean recipe. Uncertainties were honest and large, yet even a broad bracket alters the contour of theory. The isotopes refused to be identical to typical local values in detail, and that refusal was precious. High-resolution Echelle work turned to the subtle embroidery of forbidden and permitted lines. Spectra that split a nanometer into 1,000 parts found the coma breathing in its own way. Line widths gave expansion speeds, and slight asymmetries were clues to jets that do not share the same efficiency across the surface. By observing at several phase angles, the dependence of fluorescence on geometry could be separated from production rates. The coma became not just a fog, but a wind map. The dust continuum carried color that could be summarized in a single phrase. The slope was often red, meaning it brightened toward longer wavelengths in the optical. That redness can imply large, rough grains or a population of organics on the surface of the dust. Polarimetry, as a function of wavelength, added texture to that number. The degree of polarization against phase angle traced the size regime of grains and the porosity that determines how sunlight is scrambled on contact. A gentle maximum in polarization at modest phase hinted at fluffy aggregates that had grown by sticking rather than melting. Models translated these signatures into numbers that could stand in journals. The Hazer scheme, elegant and old, converted line fluxes to production rates by assuming a fountain of parent molecules that decay into daughters as they fly. Vectorial descendants improved realism by allowing children to inherit parent velocities. For crowded regions near the nucleus, solutions of the radiative transfer problem were needed to account for optical depth in strong bands. The gentle shockwave that gathered at the outer reaches of the coma left its watermark as well, because collisions and fields alter how often excited states are de-excited by encounters rather than by light. A spectrum is never just chemistry. It is also the result of transport. Sometimes the spectra were quiet where songs were expected. An absence of certain organics at levels that instruments should have caught meant that either the nucleus had been skinned by space, weathering into a protective crust, or that its birthplace had been unusually lean in particular molecules. Silence on a line is not absence in truth. It is an upper limit that disciplines speculation. That discipline guarded the narrative from easy myths. All of these measurements required choreography. Telescopes watched at multiple wavelengths within hours of each other so that short-term variations in output could not counterfeit chemical differences. Slits were aligned to capture both the central condensation and the antisolar tail so that spatial gradients could be folded into retrievals. Absolute calibration demanded visits to standard stars before and after. The night does not forgive carelessness in such matters. Scraps of uncertainty multiply if not pinned with thought. Spectra from a traveler like this do not read like a single postcard. They arrive in a bundle, stamped from far away, carrying scenes that do not quite match because the camera moved and the weather changed, and the sender wrote on several days. Yet a unity emerges when the bundle is spread on a desk. Water stands at the center because life and habit place it there, but a dozen other species lean close enough to be noticed. Dust lays down a soft background, silicates hum quietly in the heat. Sodium draws a line as thin as silk, and isotopes sketch a compass that points toward climates this star never knew. It is enough to say that the light is honest. It will not guarantee a birthplace by address, but it will say north or south of a temperature, east or west of a pressure, and that is sometimes more useful than an exact street. When the bundle is finally sorted, the ink tells a gentle truth. The visitor is kin to comets, fashioned in cold and unrest. It carries volatile reserves that wake with sunlight, and a mineral memory that preserves both order and disorder in a single spectrum. It is not a mirror of the local families. It is not alien beyond understanding. It sits between those poles with the calm of a messenger who knows the route through many towns. The postcard speaks softly, and in its softness it gives permission to imagine a galaxy where such messages are common, and where every spectrum taken in patience is a small education in how stars raise their icy children. Dust left the surface like soft handwriting, each grain a letter that carried a private history. Sunlight lifted the smallest first, then the larger, until a spectrum of sizes drifted outward in a slow parade. The parade did not dissolve into chaos. It arranged itself by rule, and the rules turned the dust into a chronicle of making, breaking, and waiting in deep cold. When the glow was measured through filters, the color leaned toward red, a hint that grains were rough and mantled with organics. When the same glow was measured through a polarizer, the angle of scattered light wrote curves that rose, dipped near small phase angles, and crested again, the signature of porous aggregates rather than polished stones. The curves served as fingerprints of structure, telling how loosely the monomers were packed, how the voids between them conspired to send light in favored directions. A simple number began the conversation with observers. Afro, a product of albedo, filling factor, and photometric radius, provided a distance-independent measure of dust productivity. It could be tracked night by night to learn whether the fountain of grains breathed in rhythm with rotation or faded as mantle hardened. The value did not pretend to precision beyond its design, yet it compared epochs and geometries with an honesty that preserved trends. A second number, the dust-to-gas ratio, carried deeper consequence. When dust mass matched or exceeded the mass carried by the major volatiles, models of ejection found a stiffer problem to solve. Cohesion had to be overcome not just for flex but for clumps with inertia and memory. The ratio thus hinted at surface strength and subsurface porosity, the engineering of a worldlet born in a disk and aged among stars. Radiation pressure separated the youngest travelers from the faithful. The push of photons acted like a wind that never tires, accelerating the smallest grains until their path bent into the familiar sweep that painters imitate when they draw a comet. Grains carried a number in secret, the ratio of radiative to gravitational force, set by size, composition, and reflectivity. The number sorted the grains along the tail without needing to ask a date of birth. Once sorted, Their geography could be read with models that place curves called synchrones and curves called syndines across the sky. One family traced release time, the other traced size. Where the curves interlaced, the age of a feature could be guessed, and the strength of the ejection could be constrained. The largest grains refused the glamour of the tail and trailed the nucleus along its path, a dim band that sometimes appeared as a trail in long exposures. Their inertia made them remember the orbit itself, not the push of light. When an antitail lifted near the plane of the sky, it was not a defiance of physics, but a perspective trick that aligned the slowest dust with the eye. Such perspective was a gift, because it allowed a separation of populations by angle, an extra axis in the problem of memory. The map that resulted was not static. It evolved with the angle between sun, comet, and observer, and the evolution was a set of lessons in how finely the dust had been sifted on departure. Microscopes were not at hand, so theory supplied one. Grains were treated as fractal aggregates, clusters of smaller monomers bound by van der Waals forces and shaped by gentle collisions during their birth in a disk. Their fractal dimension described how open or compact they were. Open structures scattered light with high polarization at modest phase, while compact ones dimmed the crest and shifted it. When spectra suggested organics on the surfaces, the refractive index adopted those mantles, and simulated phase curves moved toward the measured ones. In this way, dust taught composition without anyone holding a grain in a beam. Thermal emission added a second microscope. The brightness of the continuum at infrared wavelengths depended on how efficiently grains radiated heat and how quickly they cooled as they moved into shadow behind each other. A color temperature higher than equilibrium implied small sizes that heated quickly. A slope at long wavelengths spoke of emissivity that dropped with size. Humps in the continuum outlined silicates that had been glimpsed in another band. Their shapes here refined the distinction between crystalline and amorphous forms, and that distinction reached backward into the making of the parent disk. Crystals implied high-temperature processing or radial mixing that moved heat outward. Amorphous material implied preserve of cold or later damage that erased order. The coexistence of both states inside the same plume made a quiet argument for a birthplace that was neither simple nor uniform. Dynamics held another layer of texture. Gas dragged grains from pockets and cracks, using jets as conveyor belts. Rotation swept the belts across space, carving fans and spirals that a long sequence of images could unwrap into a clock. When features repeated, a period could be drawn without ever seeing the nucleus. When features shifted line by line, the clock also recorded precession or changes in vent supply. Even breakups became legible in dust. A gentle fragmentation cascade produced an excess of fine grains, reddening the continuum and lifting polarization in a way that statistics could detect. Sudden disruptions produced sheets that thickened tail brightness along narrow angles, then dissolved as radiation pressure resorted the pieces. Every pattern translated to a mechanical story about strength, cohesion, and the labyrinth of voids within the crust. Charge altered the fate of the smallest grains. Ultraviolet light and plasma encounters lifted electrons, leaving grains with electric potential that let Lorentz forces compete with gravity and radiation pressure. Near the nucleus, where magnetic fields draped like ribbons around the expanding coma, the tiniest grains wove paths that normal intuition misreads. Their contributions to light were subtle, yet their behavior mattered, because they set the lower end of the size distribution and helped determine how quickly the coma cleared after a flare of activity. The clearing time, in turn, fed back into estimates of pore size and the thickness of the layer that sunlight could animate. Memory persisted at chemical scales, too. Organics embedded in grains, shielded from direct sunlight, behaved like time capsules, preserving the slow imprint of cosmic rays in altered bonds and broken rings. When such grains finally entered the furnace of near-solar space, they released fragments that showed up as faint features in emission and as softness in the continuum slope. These signs testified not only to composition but to exposure history. A memory of interstellar radiation had been carried across light years and then poured into the spectrum in a few weeks of warming. When the dust was counted by size, a power law often fit well enough to proceed. The index of that law said whether mass resided mostly in the large or the small. Indices near 3.5 shared mass across scales, while steeper indices gifted the coma with more cross-section per unit mass. That cross-section brightened the coma efficiently without demanding unrealistic reservoirs of material. Deviations from a simple law, small ripples in the distribution, hinted that the release mechanism did not treat every size equally. Weak crusts broke at certain scales first. Gas drag favored sizes that matched the speed and density of the flow. Stresses from thermal cycling pried apart aggregates at their weakest bonds, creating families of fragments that resembled each other down the cascade. Modeling tied these clues together with the restraint that observation demands. Finson-Probstein calculations layered on realistic ejection velocities and mixed-size distributions to reproduce the arcs, spikes, and veils seen in processed images. Mi and T-matrix scattering models mapped refractive indices to phase curves and polarization. Radiative transfer codes added the effects of optical depth near the brightest jets. None of the tools promised unique answers, yet together they fenced the possibilities in a useful way. They made it possible to say that the dust was fluffy rather than glassy, that grains carried organics as well as silicate cores, that jets were focused by local topography, and that ejection favored certain longitudes in sunlight. The chronicle written by dust is not a simple biography. It is a palimpsest. Embedded in one plume are the fingerprints of a natal disk, the marks of gentle sintering, the stamps of cosmic rays, the scars of countless micro-impacts in a cold environment between stars, and the fresh inscription made by the sudden heat of a new Sunday. Reading that palimpsest asks for instruments that can measure color and polarization with care, for programs that can track features long enough to see a rotation inscribe itself on the sky, and for patience when models argue among themselves. The reward is a sense that even the faintest haze around a distant nucleus is articulate. It remembers temperatures and pressures that no ship has measured. It remembers habits of sticking and breaking that shaped pebbles and boulders in a young system. It remembers routes through voids, where only the slow rain of particles could write anything at all. In that way, dust serves as the oldest witness available to a traveler that reveals little else directly. It carries the archive that ice keeps hidden and rock resists showing. Grain by grain, it teaches how worlds begin, how surfaces harden, how fragments depart, and how silence stores information until sunlight persuades it to speak. A plume can be hushed and still keep faith with its story. Anyone with a sensitive eye and a steady method can listen for that story in the color of scattered light, in the kink of a tail, in the crest of a polarization curve, and in the soft bright trail that follows the path long after the nucleus has moved on. The arithmetic of comets has a comfort to it. Brightness should rise as sunlight strengthens, fade as distance grows, and carry a slope that traces the vigor of sublimation. Dust should redden predictably with phase, polarization should crest at familiar angles, and the gentle thrust from vents should tip the orbit by amounts that models can anticipate. Yet the measurements gathered across quiet nights began to lean sideways. The lean was not dramatic. It was the kind of tilt that makes a practiced observer put a finger to the lip of a coffee cup and think. The simplest clue came from light. The absolute magnitude derived from early photometry implied a nucleus larger than later estimates could accept. As geometry improved and coma subtraction grew more confident, the core proved modest. The excess light had been supplied by dust that was too efficient for the measured gas production. Dust-to-gas ratios wandered above unity by factors that demanded either fragile aggregates that detached with ease or pockets of pressure that opened pathways through a crust without boiling oceans of ice. Brightness no longer translated cleanly into inventory. It translated into a surface that seemed to know tricks. Another quiet deviation unfolded in the distance law. The classic dependence of activity on heliocentric distance assumes that water shoulders the load inward of several astronomical units, while carbon monoxide and carbon dioxide carry the early and late seasons. The light curve refused such a tidy handoff. Weak but persistent activity stirred at distances where CO2 should have slept, unless glare found fissures that opened on reserves protected from age. Later, as the object approached warmer latitudes of space, water did not take uncontested command. Forbidden oxygen lines signaled a chemistry where CO2 continued to contribute in proportions that made thermodynamic tables look like suggestions rather than rules. The changeover from one volatile to another was not a step, but a braid. Non-gravitational acceleration complicated the sketch. Residuals in orbit fits asked for a small push that could not be blamed on gravity alone. The push was real, but its vector misbehaved. It did not point cleanly away from the sun as a uniform vapor plume would demand. Instead, it wandered with a patience that suggested an uneven distribution of vents, combined with rotation that precessed more strongly than a simple body would allow. When the models tried to match both the amplitude and the direction, they had to give the nucleus a torque memory. Outgassing did not just shove, it twisted and kept twisting even as active areas drifted into shadow. The spin state swelled to a multi-periodic problem, with a main rotation wrapped by a slower wobble, an arrangement that would be ordinary only if the interior were a loose confederation rather than a monolith. Polarization added its dissent in the mildest voice. The phase curve climbed as expected toward a maximum, and yet the wavelength dependence refused to settle where common catalogues would place it. At small phase angles, the negative branch dipped deeper than predicted by aggregates of the usual porosity. That dip hints at surfaces with unusual roughness at micron scales, or at mantles of organics, whose imaginary refractive index is not friendly to simple analogues mixed on Earth. Such subtleties mean that light found a texture it did not expect, a fabric woven by processes that had stitched grains together under conditions unlike the ordinary recipes of local comets. The coma's color shifted in a way that unsettled habit further. As the object warmed, the red slope of the dust continuum softened rather than steepened. Fresh comets often grow redder when small grains dominate the cross-section. Here the trend inverted at certain times, as if grains were aging in days rather than centuries, their surfaces altered by photolysis so rapidly that color marched toward neutral while production increased. Another possibility asked to be considered. If jets dragged up pebbles just large enough to radiate efficiently in the infrared while contributing little to optical reddening, then the thermal spectrum would rise while the color cooled, a mismatch that forces a model to account for a size distribution with a moving hinge. Spectra of gas joined the soft rebellion. Ratios that connect Cn to C2, used for decades to draw taxonomies of enrichment and depletion, refused to stand still. On one night, the pattern looked like a family known for carbon chain depletion. On another, it crept toward the richer class. And yet the change could not be blamed on calibration. The culprit seemed to be geometry. Jets aimed in different directions, swept the slit differently, and the spatial scales on which daughter species are born and die shifted the measured balance. The behavior is not lawless, but it warns that old categories wobble when applied to a visitor whose vents operate from a surface that may never have learned the same seasonal rhythms as local kin. Thermal models felt the pressure next. If water did not dominate when and where it usually would, then the sublimation curves had to be pinned to a crust, with path lengths that kept pressure alive beneath sunlit skin. The temperature field inferred from rotational lines did not want a surface that obeyed simple conduction. It wanted layers with differing thermal inertia, stacked like thin quilts, a structure compatible with an origin in a disk, where fine dust and ices were deposited in alternation, and later desiccation created pockets that breathe through rare throats. When such a quilt rotates, it does not share heat kindly. Morning can wake one seam while another remains night, and jets born at those seams ignore the symmetry that textbooks prefer. The tale wrote in its own understated dialect. Kinks formed and revived at cadences that did not match solar wind rotations alone. A steady breeze from the star was certainly part of the story, but the pattern asked for internal pacing as well. Spiral fans near the head, unwrapped by image sequences, betrayed a rotation period that modulated dust release, and the kinks in the ion tail responded as if a whistle were blown from the nucleus itself. That kind of synchrony implies that the frontier where plasma meets neutral gas felt a pulse from within, a pulse that few comets transmit so clearly. Sodium's narrow voice grew too loud for comfort in one stretch of data. The resonance doublet strengthened against the continuum, beyond what ordinary sputtering from grains would explain. The shortcut explanation would be a reservoir that releases alkali easily. The more interesting one would be a fresh exposure of crust broken by stress from torque, revealing salt-rich layers that had been sealed by irradiation for eons. Such layers would alter surface charging and cohesion, setting the stage for the next subtle difference in dust behavior. No single option won the argument in full, but the options themselves rearranged assumptions about the way small worlds store their chemistry. If brightness is a vote, Then outbursts are the campaign speeches. A handful occurred at times that did not align with tides or geometry that usually trigger events. The rises were modest in amplitude and restrained in duration, as if doors opened under gentle pressure rather than walls collapsing. Photometric decay after each event was not perfectly exponential. A broken power law fit the tail of the light curve better, hinting at a mixture of fine spray and clumps that held cohesion for a while before relenting. These temperate outbursts left minimal debris trails, yet their timing challenged complacency. They asked models to consider the scheduling power of internal gas pocket networks, whose own clocks are set by diffusive timescales rather than by sun angles. Across all these small deflections from expectation, a common narrative took shape. The object was not fond of extremes. It refused to be stubbornly volatile poor, or extravagantly volatile rich. It did not boast violent jets that carve theatrical spirals or stand still with a coma as smooth as fog. Instead, it taught by nuance. Its rules bent quietly, in increments that demanded instruments working near the limits of their sensitivity, and analysts willing to respect patterns that do not announce themselves loudly. The reward for that respect was a portrait of a nucleus whose architecture and chemistry were both more intricate and more reluctant to generalize than the handbooks imply. The lesson that lingers is modest and difficult. When matter spends ages among stars, small differences in birth and weather accumulate into habits that resemble personality. If a body like this alters phase curves by a few percent, or drags a non-gravitational vector a few degrees off the expected line, or braids volatile contributions in a way that slips past standard distance laws, those are not nuisances. They are the signal. They say that the physics is intact, but the initial and boundary conditions belong to another nursery. To read that signal requires a willingness to let the rules flex without assuming they have broken. The bending is the biography. It is the soft accent carried across light years that remains even when vocabulary is shared. Photons arrived one by one and were counted with the patience of a tide clock. Each count was a small bead added to a string, and the string grew long enough to suggest a rhythm inside the glow. The method looked simple on the surface. Aim, expose, subtract the sky, divide by a reference star, repeat. The deeper craft lived in all the ways that light can fool a sensor. Scintillation trembled the counts. Thin cloud imitated faint haze. The coma blurred a nucleus into a soft lantern. Against that list, a discipline formed. Apertures were chosen with care. Annuli were used to sample background. Reference stars were selected for color that matched the object so that atmospheric extinction would cancel as much as nature allowed. A light curve took shape from this discipline. It was not a straight line. It swelled and sank in a pattern that asserted a clock inside the body. The pattern asked for mathematics. A Lomskargel periodogram tested unevenly spaced nights and returned a handful of candidate periods that circled a central value like planets around a star. Pre-whitening removed the strongest beat to see what remained. A second rhythm surfaced, quieter and real. Wavelet transforms laid the two clocks on a time axis and showed both intensity and drift. The body did not simply spin. It also wobbled with the dignity of a slow top, a non-principal axis rotation that comets favor when torque accrues unevenly over years. Amplitude carried its own story. The heights and depths of the curve were not symmetric. Peaks arrived slightly sharper than troughs, and that asymmetry refused to wash out as geometry changed. Two interpretations competed without heat. One said shape was the author. An elongated nucleus would present a broad side and a narrow side in alternation, and reflectivity variations across that shape would emboss the peaks with character. The other said activity wrote the accent. Jets that turned on and off with illumination would ride on the rotational modulation and sharpen the moments when the active face showed. Both could be true. Both likely were. Coma subtraction stood at the center of honesty. The raw aperture included a fog that did not belong to the nucleus. That fog had its own brightness gradient that approximated 1 over radius. A simple model of that gradient, scaled to the annulus around the core, and then removed, cleaned the curve without pretending to resolve the nucleus directly. When activity surged for an hour, the model failed in exactly the way good models should fail. Residuals spiked. Analysts acknowledged the spike and marked the interval. No one edited away the story in the name of beauty. Phase angle correction refined the music. As the Sun-Comet observer angle changed, surface facets slipped in and out of mutual shadow, and the light curve amplitude drifted. Hapke-style functions or simpler phase laws were applied to the baseline so that the remaining undulation could be blamed more directly on rotation and jets rather than on geometry. Opposition surges near small phase angles tried to counterfeit real brightening. They were corralled by comparing with reference stars at similar angles, and by using nights when the phase angle bisector changed little across the run. A surprise lived inside the long string of nights. The principal period lengthened by a measurable fraction of a second per day over a span where thermal forcing did not change dramatically. That slow drift is the signature of torque. Outgassing from vents can act like thrusters placed on a lumpy spacecraft. If the thrust is not perfectly balanced across longitudes, it feeds or steals angular momentum. The sign of the drift suggested braking. The nucleus was losing spin speed quietly. Moments later in the data, the wobble period also adjusted, as if the interior were a pliant confederation of blocks rather than a single stone. Such pliancy fits a structure rich in voids and weak bonds. Color photometry folded another layer over the light curve. Alternating filters revealed a gentle change in color with phase. Sections of the rotation showed redder slopes in the visible, then cooled toward neutral. The pattern repeated with the main period and not with the wobble, which hinted that an active longitude carried a veneer of organics or fine dust more than its neighbors. Gas filters told a parallel tale. CN and C2 bands rose out of step with the continuum on some rotations, a separation that marked zones where jets originated in patches chemically distinct from the average surface. An ensemble of telescopes wrote the curve together. Instruments with apertures from 20 centimeters to 8 meters participated, linked by standardized procedures. Differential photometry with 3 or more comparison stars in each field created redundancy against the failure of any single reference. Timestamps were disciplined by GPS or rubidium clocks. Small observatories contributed cadence. Large ones contributed depth. The combination prevented aliasing from poisoning the period solution and made sure that a busy week did not erase the fine structure gathered by a lonely night elsewhere. When gusts of brightness punctuated the regular beat, their shapes mattered. Some were triangular and quick, as if a narrow jet swept through the photometric aperture. Some were rounded and slow, as if a pocket bled gas through a patchwork of pores. Rise times and decay times were fitted with functions that spoke to the size of the contributing dust. Fine spray brightened rapidly and faded rapidly. Coarser aggregates hung longer in the aperture before drifting outward and dimming. Fourier residuals, after subtracting the rotation, indicated that the events carried their own frequencies, and those frequencies lined up with harmonics of the main spin. That lining up is the telltale of vents, anchored to specific longitudes. The tail of the light curve in time revealed episodes of peeling. After certain outbursts, the baseline did not return to its prior mean. It settled slightly dimmer, and then recovered over several rotations. Such steps point to temporary loss of optically efficient grains from the central aperture, as if a fragile coating had sloughed off and exposed a surface that scattered light differently until fresh dust restored the blanket. When this interpretation was tested against polarimetric changes, the angle curves shifted in sympathy, confirming that grain populations had been reset. Nights of exceptional seeing permitted a finer trick. The point spread function of nearby stars was used to model the central condensation of the comet. Subtracting that model left a residue that traced inner jets at scales just above the seeing disk. Rotational phasing aligned those jets with peaks in the photometric curve. The alignment was not perfect, and the error bars had honest breadth. Yet the coincidence appeared too often to ignore. In combination with the weak, non-gravitational acceleration, the pattern identified a set of active zones that did more work than their share. Secular trends tested patience. As the object moved across the sky, a slow rise and fall tied to distance tried to drown the small variations that held physical meaning. A composite curve normalized the flux by the classic r to the minus n law with n near 4 for dust-dominated brightness. Removing that slope revealed the superposed rotation cleanly. Experiments with n from 3 to 5 bracketed the uncertainty seen. The rotation signal remained robust across the bracket. an indication that the particular choice of slope did not invent the apparent clock. Instrumental systematics were treated with suspicion. Flat fields were refreshed nightly. Fringing in the red was measured and corrected using twilight sky frames. Shutter timing was calibrated so that sub-second exposures did not carry invisible offsets. Barycentric time corrections were applied so that the period solution did not absorb Earth's motion. When seasons changed and different filters were used, color terms were measured and applied to maintain a single photometric system. Only after this catalogue of care did the light curve earn the right to be interpreted as a property of the object rather than of the instruments. Models of the nucleus took the curve as a constraint. Simple biaxial ellipsoid shapes with Lambertian reflection could match the amplitude, but not the asymmetry. Adding albedo variegation produced better fits. Introducing a handful of active areas that switch with sunlight improved the phasing of minor peaks. Allowing a free precession captured the slow wandering of the secondary period. None of the models claimed uniqueness. They claimed plausibility, and in the space between data and uniqueness lived a set of truths. The body is elongated enough to matter. The surface is patchy enough to matter. The spin state is complicated enough to matter. What emerged from thousands of points was not a single number but a personality curve. The rotation period lived near a value that could be written down to the second, yet it carried a derivative with time. The wobble owned a slower beat that shifted as torque accumulated, and perhaps as mass moved internally along fractures and pores. Active longitudes contributed narrow shoulders to the peaks and sometimes turned a single crest into a double. Peeling events nudged the baseline and taught how quickly a small world can rebuild its optical skin under modest activity. Instruments returned to the same star fields months apart and found the same comparison lights waiting. The curve reassembled with familiar peaks and new subtleties at the margins. The method stayed humble enough to respect noise and ambitious enough to wring meaning from a few percent of variation on top of a slow secular trend. A trail of clues had been laid down by photons that could not know they were part of a biography. Anyone with a clear sky, a good clock, a careful hand, and a willingness to share data could help write that biography. The result was a portrait in rhythm, a proof that even a faint traveller carries a pulse that can be heard if listening is long and quiet enough. Birthplaces of icy wanderers begin as whispers inside disks that circle infant stars. Dust meets dust, and keeps meeting until pebbles form, then boulders, then bodies large enough to grip nearby fragments with gravity. Around them, gas still swirls, thick enough to break motion and slow collisions, thin enough to let lucky objects slip away from fatal impacts. In such neighborhoods, young planets behave like impatient neighbors. They jostle, they trade energy, they kick small worlds into new lanes. Some lanes curve inward toward heat, some turn outward into dusk. A few become ramps that do not return. The simplest ramp is gravity itself. A giant planet does not need malice to hurl an object away. A close passage suffices. The small world falls in, gains speed, turns a corner around the giant, and rises out carrying the giant's orbital energy as a gift. If the angle is right and the timing precise, the gift is large enough to break the star's hold. Jupiter has modeled this lesson for centuries, scattering local comets into long periods and, on occasion, into exile. Any system with one or more giants can repeat the trick. The efficiency of ejection rises when several giants trace orbits that lean into resonances, because resonances herd objects into repeating encounters that keep turning the same key until the lock opens. Disks amplify the process. Gas drag slows the smallest bodies, but it also damps their inclinations and eccentricities, pushing them toward the midplane where giants harvest them more easily. Pebble accretion builds cores quickly, and those cores sow chaos early. As giants migrate through the gas, they sweep resonances across belts of debris, kicking some fragments inward to become fodder for rocky planets, and kicking others outward into vast reservoirs that resemble distant clouds. When the gas thins and the migration stalls, the giants remain as engines. Their gravitational reach continues to pump energy into small bodies that stray too near. Over tens of millions of years, a steady leak of escapees feeds the space between stars with cold archives. Binary stars complicate the scene with generosity. A second sun raises tides in the disk and in later belts of debris. Those tides can shake small bodies loose from otherwise safe niches and hand them off to the more massive partner for a decisive kick. Wide binaries act like slow hammers. Tight binaries can carve the disk early and prevent planets from forming near the center, shunting growth to outer regions where giants must share space with thick belts of ice. Crowded outskirts plus restless primaries become fertile ground for ejection. The same mechanics that expel fragments also roughen the surfaces of those that remain, implanting a memory of stress in their crusts. Star clusters add a further hand on the lever. Most stars form in company. Nearby suns pass within a fraction of a light year during the first 100 million years, when disks are still warm and planets are still choosing their lanes. Each passage raises a tide that tilts, or stretches, or compresses a shape of orbits. On some nights, a neighbor's tide lifts the aphelion of a comet cloud until it slips into interstellar current. On other nights, a passing star steals rather than loosens, capturing an exile from the next system. The exchange is not theft in any moral sense. It is the noise of a marketplace at the beginning of time, where goods are traded without receipts and the stalls have no walls. In that market, supernovae play percussion. A massive star that ends with a shout floods nearby space with radiation and a pressure front that can scour disks and clouds alike. The front does not need to be close to make a difference. A distant blast arrives as a long breath that peels away gas, lowers the mass that binds the outermost objects, and leaves orbits vulnerable to smaller kicks. The same shock compresses some regions, igniting next generations of stars. Ejecta carry heavy elements that will seed future dust with exotic ingredients. A few ice-rich bodies ejected during that season may carry, in their isotope ratios, the faint grammar of a neighborhood that felt both nurture and violence. Secular dynamics carve slower, insistent paths to exile. When several planets share a system, their combined pull can transfer angular momentum among small bodies in ways that take millions of years to matter. Kozai-like cycles tilt orbits until a body's perihelion dives toward danger, where a giant waits to finish the work. Mean motion resonances act as holding pens that raise eccentricity by steps, each step making an encounter more likely. In simulations, the result is not fireworks but attrition. Objects leak away through a few preferred exits. After billions of years, the exits have processed enough travelers to make a galaxy quietly busy. Chemistry sets the starting conditions for these journeys. An ice-rich surface binds gas at low temperatures and releases it when heated. If fractures form, volatile pressure can help a weak encounter become a decisive one by adding a little push at the wrong moment. Sublimation recoil is tiny, but time multiplies tiny things. Over many perihelion passages in a youthful system, even mild activity can alter orbits enough to line up a close pass with a world capable of lending escape velocity. Layered ices that formed at different temperatures contribute at different ranges from the star, turning the clockwork of activity into a set of windows where small impulses matter most. Some bodies leave in pieces rather than whole. Tidal encounters with giants can stress a porous object into fracture. The fragments inherit slightly different velocities and therefore slightly different fates. A subset gains the extra meter per second needed to leave forever. The rest settle into transformed paths, some safer, some doomed. The fragments that escape carry fresh faces into the dark, surfaces newly exposed by the tear, surfaces that will weather in interstellar radiation for ages before the next sun warms them. Radiation fields outside the protection of a heliosphere work on these exiles without pause. Cosmic rays pockmark crusts, break large molecules, and create hard skins that slow sublimation when a body finally wanders near another star. That weathering does not expel objects. It seasoned them. A crust resistant to heat can keep a small world intact during a fast pass close to a new sunday. Intactness matters, because detection often depends on activity that lifts a coma. Paradoxically, a crust can both inhibit and preserve. If it yields at only a few weak seams, then activity will appear mild. If it holds everything else in place, the body will survive the pass and leave to drift again, ready to be read by distant instruments. Escape also comes from absence, not only from encounters. When a disk loses gas quickly, pressure support that helped steady the orbits of small bodies vanishes. Without that cushion, weakly bound objects in the outskirts feel the full tug of planets and tides. Some slip out simply because the star's gravity is no longer buttressed by the gas that once slowed them. In this sense, ejection can be a final chapter in the story of disk dispersal. Photoevaporation by ultraviolet light from nearby massive stars accelerates the thinning, making entire neighborhoods leakier than they would be in isolation. Galactic tides, the faint pull of the larger mass of the Milky Way, write longer notes. At distances far from a star, where comets wait like cold seeds, the tide tilts orbits slowly until other players have easy access. The process is delicate, but it continues forever. If another star passes while the tide is lifting, a body that was nearly safe finds itself nearly free. The compound probability across billions of years is not small. It implies that every planetary system contributes a rain of small exiles to the galactic sea. The rain is light compared to the mass that systems keep, but the absolute number is vast. Once free, trajectories are set mostly by inertia. A traveler leaves its sun with a speed of a few kilometers per second, relative to its home, gains or loses a little from the motion of that sun around the galaxy, and joins the slow traffic that meanders between spiral arms. Some exiles carry scars from the last shove. Some carry only the patina of age. Their velocities relative to random suns vary, but even modest differences are enough to cross the domains of many stars over cosmic time. Most passes go unnoticed. A few align with a path through the inner regions of a foreign system, where instruments now wait. Across all these mechanisms lies a principle that is both simple and generous. Planet formation is messy. Messy processes waste material. The waste is not garbage. It is a library bound in ice and dust, each volume stamped by a different workshop of temperature, pressure, and composition. Scattering and tides distribute the library through the galaxy. Every now and then, a reader opens a book by pointing a telescope and letting light do its quiet translation. The origin lives in the between, in the turbulent intervals where order forms and then throws away pieces of itself to make room for stability. Those pieces travel for ages and deliver their pages to any civilization that takes the trouble to read. Chemistry arrived like a shuffled deck, each card a ratio that could reorder the story. The light did not merely describe species. It measured relatives and cousins, their proportions tilted by temperature, pressure, and time. Some ratios were ordinary, the kind that place a traveler inside the broad family of icy bodies. Others edged away from habit, an angle of difference that hinted at a nursery with weather, unlike the local pattern. The gamble lay in reading those angles without forcing them into a script written for other skies. Water stood at the center because it is both common and telling. In its fragments live clues to infancy. The deuterium to hydrogen ratio converts photons and lines into a pale thermometer. Values near the local median would say the ice condensed in regions not radically colder or warmer than familiar comet zones. Values that climb speak of storage in deep cold, or of fractionation during long residence in porous matrices where diffusion favors the light. Measurements on this visitor bore generous uncertainties, as interstellar surfaces tend to hide under crust and activity can be mild, yet the brackets still fenced the possibilities. The fence did not match the extreme of every local family member, and that alone mattered. The message was quiet. The ice remembered a climate that overlapped ours and then wandered. Carbon traced another temperature scale. The balance between carbon monoxide and carbon dioxide, set against water, places a foot on the map. Carbon monoxide survives only when the nursery is cold or when the ice is buried in shadow such that it never had to choose between freedom and imprisonment. Carbon dioxide stands as an intermediate, liberated at warmer distances from the star. If both contribute deep into the inner regions, the nucleus must host reservoirs sealed behind insulating skins. If only one sings loudly, the crust and the pore network decide which breath escapes. For this traveler, carbon dioxide did not retreat meekly, and carbon monoxide showed itself more often than a strict reading of equilibrium would predict. The pairing suggested that the object carried layered memory, a quilt of ices assembled from zones that were neighbors but not twins. Nitrogen carried poetry of its own in the balance between 14 and 15. Ratios here can hint at photochemistry in the disk's ultraviolet upper layers, at inheritance from molecular clouds, or at later alteration by radiation that drives selective bond breaking. Values nudged away from local norms. Ask for different doses of those processes. Cyanogen lines, sensitive and sharp, offered the numbers with care, and ammonia's descendants whispered too, although they are subtle witnesses. The inference did not require exotic scenarios. It required patience for the idea that no two disks distribute light and shadow in exactly the same way. Oxygen's isotopes are an older ledger, written when dust and gas exchanged in the dawn of a system. They carry the footprints of self-shielding in molecular clouds and the imprint of ice-line migration. When forbidden oxygen lines in green and red are parsed with skill and folded through models that track parentage from water and carbon dioxide, they sketch the slope of the oxygen story. Here the slope neither screamed novelty nor resigned itself to sameness. It hinted at a lineage where exchange with gas had been less efficient than in some local kin, a quiet sign of a nursery with slightly different mixing. Organics wrote in colors and in dusty perfume. The families known as C2 and C3, long used as a taxonomy for comets, gave ratios to Cn that drifted with geometry and with the breathing of jets. On some nights, the pattern mimicked carbon chain depletion found in a subset of local bodies. On other nights, the pattern softened toward richness. The oscillation made a different point. The source regions on the surface are variegated. Some patches release fragments born from complex organics that cook into chains under sunlight. Other patches feed the coma with precursors that prefer not to cook. A single classification could not be stapled to the object without acknowledging the surface mosaic. Sodium appeared as a narrow thread in the spectrum, a feature that often serves as a tracer of dust processing. When that thread brightened against the continuum beyond expectation, it asked whether the grains carried an alkali memory from parent minerals or from evaporite layers laid down during brief warming episodes in the home system. A traveler bearing such layers would not be entirely primitive in the strictest sense. It would be a mixture of untouched ices and processed veneers, the result of a protoplanetary neighborhood that did not leave every region in permanent winter. To understand the gamble, comparisons mattered. One earlier visitor carried a brightness without a visible coma. Its chemistry inferred from absences and from a gentle acceleration that could be explained by outgassing of invisible molecules or by the recoil of trapped hydrogen or by physics not yet settled. That traveler refused to open a spectral book. The next carried an obvious coma that leaned on carbon monoxide, a cold signature that placed its birthplace farther from warmth or under deep cover. Against those two, the current visitor sat between. It produced a spectrum that spoke plainly, yet it did not choose extremes. Carbon monoxide was present, but not tyrannical. Carbon dioxide remained articulate near the sunday. Water worked without monopolizing the scene. Organics were neither gaudy nor sparse. The portrait resembled a median drawn through a diverse family, but not a compromise made dull by averaging. It looked like the chemistry of a disk with active stirring, where pebbles and ices migrate and mix before being built into larger bodies. Dust supported that reading. Silicate features at 10 and 18 micrometers rose with shapes that balanced crystalline shoulders against amorphous breadth. Crystals imply journeys through heat or inheritance from material annealed near the star and then flung outward. Amorphous humps imply condensation in cold, with little subsequent warming. If both live together in the same plume, the parent body spent its childhood in lanes visited by both furnaces and shadows. That dual citizenship aligns with volatile ratios that refuse to pick a single temperature as home. Radio lines delivered a tighter clutch of facts. Methanol and formaldehyde traced chemistry that often blooms when radiation damages larger organics and leaves smaller fragments to outgas. The pattern of rotational temperatures and column densities implied production that is not purely direct from the nucleus. Distributed sources contributed, likely from grains that release material on their own as they warm. That detail adjusts the reading of volatile ratios in the core to avoid blaming the nucleus for what the coma does later. Correcting for that, the fundamental picture stayed intact. The object was neither lean nor lush. It was complicated in an ordinary way. Spin temperatures measured through ortho to para ratios of water and ammonia added a final thread. Those ratios remember formation conditions indirectly, although later processing can blur the message. Values near low tens of Kelvin mark ice, laid down in cold phases, with little later reordering. Higher values accept some annealing or exchange. The results nudged into middle ground, avoiding the coldest signal and the warmest. Middle ground here is not indecision, it is identity. It is the mark of a body assembled from contributions across a range of radii, and then protected by crust, enough to arrive with the memory still legible. If chemistry is a gamble, the winnings are measured in what ideas must be surrendered. It becomes harder to keep a picture in which interstellar visitors belong to a narrow class, with either very volatile rich or very volatile poor natures. It becomes easier to imagine that most systems export a spectrum of bodies, and that detection bias culls the ends. A traveler with moderate activity and nuanced ratios fits this bias. It will be bright enough to be found, yet not so explosive that it erases the crust that preserves subtle isotopic messages. Its organics will be evident, but not overwhelming, easing the retrieval of weak lines. Its dust will be articulate, but not opaque, allowing gas to be heard. The implications fold outward. If many stars trade such bodies, then distant oceans and atmospheres may have received similar cargoes of organics and volatiles, altering starting lines for prebiotic chemistry by small increments that compound over time. If some visitors carry sodium-rich layers or fractures filled with salts, then evaporite cycles occur in disks more often than assumed. If oxygen and nitrogen isotopes drift modestly from local norms, then the homogeneity often drawn for planetary nurseries should be revised toward a patchwork quilt. A final caution serves the romance well. Ratios are weather vanes that point to wines long gone. The readings depend on geometry, on slit placement, on the balance between nucleus and coma, on outbursts that reset dust populations, on models that must separate distributed sources from primary emission. Yet, even through those filters, a shape appears. Chemistry does not present a mirror or a mask. It presents a softened portrait that honors both similarity and difference. In that portrait, this traveler belongs to a galactic family rich in variation, and its quiet deviations from local habits are precisely the features that make the face memorable. Tools gathered like a quiet orchestra, each instrument tuned for whispers. Wide-field surveys began the overture, their CCD mosaics sweeping the sky with a cadence that turns motion into music. Software subtracted last night from tonight and left behind the faint remainder, a traveling point almost swallowed by noise. Non-sidereal tracking locked onto that small drift, so that photons would fall exactly where they were needed. Queue scheduling and target of opportunity rules moved the target up the ladder. In that choreography of alarms and approvals, the first notes became a score. Large mirrors gave depth to the faint. Adaptive optics corrected the trembling of air, straightening starlight with rapid mirrors moved by the guesses of bright guide stars and the precision of lasers. The core of the coma sharpened. The inner jets emerged as fans and spirals that could be followed across hours. Integral field spectrographs laid a miniature cube over that sharpness, a spectrum at each point on the plane, so that chemistry could be painted as a map rather than as a single average. Where the signal was too thin for such luxury, old, faithful long slits were aligned with the tail and the sunward side, and the difference between those positions became a geometry of sources. High-resolution Echelle spectrographs unfolded the light with ruthless patience. A nanometer exploded into 1,000 measured parts. The lines of CN, OH, sodium, and forbidden oxygen acquired profiles that carried speed, not only composition. Expansion velocities could be read from full width at half maximum. Slight tilts told where jets crossed the slit. Instrumental profiles were calibrated with hollow cathode lamps, and the steadiness of telluric lines, then removed like careful scaffolding so that the building of the spectrum could stand. At radio and millimeter wavelengths, interferometers stitched dishes into virtual giants. Rotational lines of methanol, HCN, and CO became rings of emission that arced around the nucleus. The rings broadened and thinned with time, teaching how production waxed and waned, how distributed sources in the coma contributed beyond the immediate vents. Space telescopes listened where air is loud. In ultraviolet bands, fluorescent cascades brightened the coma in colors that ground-based instruments cannot see reliably. Hydrogen became a whale-size halo, mapped not as an image alone but as a reservoir that reveals the water factory within. In the infrared, cryogenic spectrographs weighed the heat of dust and the signatures of ices that stretch and bend at micrometer scales. Color temperatures and silicate features emerged with a clarity that requires zero sky background and a sensor that sees warmth as light. Observations were scheduled to bracket rotation, a safeguard against mistaking a changing face for a changing species. Polarimeters told a story that photometry cannot. They measured the orientation and degree of scattered light as a function of angle and wavelength, then wrote curves that have the grammar of texture. Imaging polarimetry overlaid that grammar on jets and fans, making fields of arrows that flipped near the nucleus and settled farther out, a map of fluff and frost written by electric vectors. Calibrations leaned on fields of unpolarized stars and on bright, stable standards, often revisited in the same night so that drift would be caught before it grew into error. Timing experiments turned distant bodies into metronomes. Stellar occultations were predicted from fresh astrometry and shared across a global network of small telescopes. Portable rigs waited on highways and in pastures, GPS-disciplined clocks ticking inside their housings. For a few seconds, a star would dim as the coma or nucleus crossed it. The pattern of dimming along a line of observers traced chords across the object's shadow and revealed size and subtle structure. The method rewarded patience more than money. The difference between a null result and a brief blink became a constraint with teeth. Photometry at scale relied on vigilance against self-deception. Standard fields were imaged before and after the target. Solar analog stars were used when gas filters demanded faithful continuum subtraction. Fringes in red filters were measured and removed. Apertures were grown outward in steps. Then the growth curves compared against expectations for a 1/over radius coma. Deviations became clues to jets rather than mistakes to be hidden. Light curves were posted into shared repositories overnight, where other observers folded theirs on top, creating a quilt in which each patch carried its own weather, and yet the whole told a larger climate. Telemetered space weather framed some decisions. When a coronal mass ejection was forecast to sweep past, ion-tail observers planned longer runs, aware that disconnection events can snap a tail like a taut wire. Solar wind parameters, measured upstream of Earth or closer to the Sun by sentinels, were used as boundary conditions in magneto-hydrodynamic models that predicted how the cometary frontier would breathe. Imaging spectrographs looked for the soft X-rays born of charge exchange, where heavy ions meet neutral gas, and heliospheric imagers watched for faint ripples that mark the interaction region where plasma slows and warms. Laboratories were part of the field campaign, though their ceilings were close. Cryogenic chambers held mixtures of water, methane, ammonia, carbon monoxide, and carbon dioxide, cooled and irradiated with ultraviolet and electron beams. The products, warmed through carefully measured ramps, were fed to spectrometers so that real optical constants could replace guesses in coma models. Silicate powders were annealed and quenched to grow crystalline and amorphous signatures that could be compared to thermal emission humps at 10 and 18 micrometers. Scattering experiments on fluffy aggregates, built grain by grain, linked polarization to porosity through direct measurement rather than faith. Numerical tools kept pace with photons. Orbit-fitting codes tested gravitational and non-gravitational models together, using Markov chains to explore covariance matrices that can hide false certainty. N-body integrations were repeated with different ephemerides and time steps to test the robustness of predictions for future sky positions and past approach directions. Vectorial coma models replaced simple fountains, allowing daughter molecules to inherit the velocities of parents, and radiative transfer solvers handled optical depth in strong bands that would otherwise be overcounted. Finson-Probstein dust dynamics laid families of synchrones and syndins against images until the age and size of tail features resolved into times and micrometers. Retrieval pipelines wrapped all of this in repeatable scripts so that new data could be digested quickly, and the same assumptions applied each time. Some ambitions pointed beyond the ground and the current fleet in space. Concepts for rapid intercept missions were sketched on whiteboards, modules that could ride co-launched rideshares or piggyback on outer-planet missions, then peel off when an interstellar target appeared. They would carry wide-field cameras, dust analyzers that taste single grains, and mass spectrometers tuned for organics and noble gases. Their propulsion budgets looked tight, their windows narrow, yet the engineering grew more plausible each year that time-domain astronomy sharpened its reflexes. Even without a launch, Planning imposed discipline on measurements from Earth. Whatever an interceptor would want to know tomorrow, a telescope network should try to know today. Data culture changed to meet the faint. Survey pipelines learned to flag unusual proper motions and to elevate candidates to human eyes within minutes. Amateur astronomers with fast optics and modern CMOS sensors joined professional programs, their images arriving with precise times and careful notes. Version-controlled codebases living in public repositories allowed independent teams to reproduce each other's reductions and to catch subtle choices that could steer conclusions. Archival searches for precovery detections were scripted into routine rather than heroics, reaching back weeks to extend arcs and shrink uncertainties. The humility of calibration returned each night. Flat fields were renewed. Throughput was measured against standard stars. Slits were aligned using field rotators, then checked against the angle to the sun so that tail and head could be sampled consistently. Guide cameras were tested for differential flexure. The shutters of photographic plates are gone, yet their spirit survives in the obsession that exposure time be honest. Only after this litany of care did numbers earn the right to be called measurements rather than impressions. All these tools, from the rural folding table with a small telescope to the space-cooled spectrograph that drinks the heat of dust, share a single intention. They listen for what is faint without pretending that faint is the same as empty. The listening is an architecture. It scaffolds the unknown with repeatable acts, ties disparate wavelengths into a single story, and refuses to mistake novelty for error, or error for novelty. In that architecture, a traveler that gives only a few photons per second becomes articulate. The speech is quiet, but the grammar is solid. With enough ears and enough patience, the faint becomes legible, and legible becomes knowledge. The work of testing began with a vow to let hypotheses fail cleanly. Models were set on the table like instruments before a concert. Each carried its own melody. Grain dynamics promised the shapes of tails and the decay of outbursts. Thermal physics claimed the tempo of sublimation through crust and pore. Outgassing torques offered explanations for drifts in spin and the slow waver of a wobble. Chemistry linked line strengths to reservoirs and to distributed sources in the coma. Plasma interaction codes predicted kinks in the ion tail and the posture of the gentle bow in the wind. The vow required predictions that could be checked with clocks and angles rather than with mood. Dust came first because it writes quickly. Finson-Probstein calculations placed synchrones for multiple release times across the sky and paired them with syndynes for grain sizes. If the assumed ejection velocities were right, specific filaments should pass through chosen pixels on chosen nights. When long sequences of images were stacked and enhanced, the filaments either appeared where they were forecast or they did not. In several runs, they arrived within the width of a seeing disk. That success pressed the model onward. In others, the features sat a few arcseconds aside. The offset sent modelers back to revise the law that links speed to size, or to allow jets that deliver preferred directions. Each adjustment came with a new date and a new pixel to check, and the habit of prediction held the adjustments to honesty. Thermal models faced a sterner trial because they reach into stone and ice without seeing either. Their forecast began with the light curve of production. Given a rotation period and a guess at thermal inertia, the output of water and carbon dioxide should rise and fall with our angle. Spectrographs were asked to visit at intervals that sampled the rotation and to record whether the predicted maxima met them on time. When the waterline brightened late, the model learned that heat did not move through the skin as freely as first assumed. When carbon dioxide lingered where it should have slept, the model learned that reservoirs were connected by channels deeper than a single sunlit layer. By the third iteration, the forecasts for both species fit within uncertainties that felt earned rather than chosen. Outgassing torques were tested with the patience of clockmakers. The rotation period measured in the light curve drifted by millisecond steps per day. A model that placed vents at preferred longitudes and latitudes, with efficiencies fixed by earlier spectra, predicted a derivative in time for that period. The sign and magnitude could be compared directly. In nights crowded with weather and competing targets, the comparison held near true. A small discrepancy survived, a sign that at least one active area wandered in strength, or that the nucleus did not carry mass evenly in depth. The discrepancy became a new prediction. If a vent grew or faded, Double peaks in the curve should trade places in amplitude at a calculable cadence. Several weeks later the trade occurred, not as drama but as a quiet tilt of the same old hills in the same old plot. Occultation tests were less forgiving. A predicted passage across a field star drew dozens of small telescopes into alignment. Timers clicked. The star dropped by a fraction of a magnitude for a fraction of a second, not full but uneven, the signature of coma structure brushing the line of sight. Several stations saw nothing, a result as useful as the blink, because it drew the cord that said how far the coma extended at that level of optical depth. Coma profiles in models were adjusted until the negative and positive chords agreed. The new profile then had to predict image brightness in photometric apertures of all sizes used by the network. Agreement across methods kept the profile from turning into embroidery. Plasma interaction codes carried the responsibility of explaining kinks that wandered down the ion tail. Solar wind parameters measured by upstream monitors fed the boundary of the model. The code returned a time for a disconnection to leave the head, and a speed for the kink to travel. Narrowband images centered on ion lines traced the event. When a predicted kink failed to appear, the model accepted that the wind had rearranged before reaching the object, or that the field line topology near the coma was less obedient than the grid had assumed. When a kink arrived late, the model learned humility about the distance between a monitor and a comet and added a spread in arrival times to future forecasts. In either case, the discipline of target times and narrowbands kept belief from wandering. Chemistry demanded a game of two halves. Parent molecules rise from the nucleus. Daughters and fragments bloom in the coma. If line ratios were to test the nucleus, the contribution of distributed sources had to be subtracted. Vectorial models allowed daughters to inherit parent velocities and lifetimes determined by light and collisions. The models then predicted how the ratios would change with slit width and with the offset from the center. Observers obliged by stepping slits across the coma, like rungs on a ladder. Ratios evolved with offset as forecast. Residuals taught where grains were feeding the gas long after the vents had done their work. A different class of test lived in the orbit fits. Non-gravitational acceleration models often assume that the push from outgassing points along the Sun-Comet line and scales with production. A more realistic treatment lets the vector stray as vents turn on and off around a rotating body. Codes that linked the torque model to the orbit fit produced residuals that could be compared with the simpler law. If adding realism did not shrink the residuals, then the realism was indulgence. If it did, then the law had earned its complexity. Over a month of data, the realistic law improved both the amplitude and the direction of the fit by small but significant margins. The win was modest. Modesty was the point. Laboratory measurements fed into tests wherever optical constants could tip the scale. Polarization curves predicted by scattering codes depend on the refractive index of mantled grains. Indices measured from ices and organics grown under radiation in cryogenic chambers replaced guesses, and the curve moved toward the data without hand-tuning. Thermal emissivities measured on silicate powders, annealed and quenched in controlled routines, refined the shapes of the 10 and 18 micrometer humps in the model. A fit that had needed a contrived mixture of minerals relaxed into a simpler blend that matched a plausible history of heat and shadow. Bayesian frameworks wrapped all these comparisons so that each test adjusted belief in a model rather than issuing verdicts in isolation. Priors came from physics and from earlier comets. Likelihoods came from residuals between forecast and measurement. Posterior distributions for parameters could be read as ranges with credibility, not as single points dressed up as truth. Where models competed, information criteria forced a cost on complexity and rewarded parsimony that did the same work. The goal was not to win arguments. The goal was to avoid explaining noise with imagination. Predictions aimed forward, because testing thrives on having something at stake. A model of dust release suggested that a faint, broad fan would open on a specific date when a certain longitude entered morning. A network of telescopes watched and reported that the fan indeed woke, weak and wide, exactly as the geometry demanded. A thermal model forecast a temporary drop in activity after a stretch of unremarkable days, caused by the passage of a cooler seam across the subsolar point. Photometers recorded the dip, shallow and brief. A plasma model warned that an oncoming solar high-speed stream would pinch the ion tail and shorten it by a measurable angle. Images taken in ion filters showed the pinch within a day of the predicted window. None of these events were bold. Their value lay in being nailed to the calendar. Failure was curated as carefully as success. A forecast of a sodium flare, built on the idea of a salt-rich patch rotating into noon, passed without a trace. That absence was not filed as disappointment. It closed the door on a family of salt layer hypotheses and directed attention to radiation sputtering as a more likely source. An attempt to link a small change in spin state to a micro-outburst produced no detectable correlation. That result stiffened the claim that most torque was being accumulated by steady jets rather than by short, sharp events. Each null result trimmed a narrative and left the remainder stronger. The testing enterprise taught a style of thought as much as it taught numbers. It insisted that novelty be invited and then interrogated until it offered something countable. It insisted that models be asked to predict pixels, times, and angles that would either show the model right or show it lost. It insisted that small wins be treated as real and that large claims be slowed until they had lived through several nights in the cold. In the doing, the object ceased to be a mystery in the diffuse sense and became a set of exacting questions that the sky could answer, given patience and care. A small visitor can recast a large home. The data gathered from a brief pass through sunlight returned a simple lesson first. Planetary systems do not close neatly once their major worlds form. They continue to shed and trade the remnants of construction. The solar system, long imagined as a finished composition, belongs to that active traffic. If other stars export cold archives into the galaxy, then this star has almost certainly done the same. Jupiter and the ice giants served as catapults in youth, launching uncounted bodies outward. Some became residents of distant reservoirs, some escaped into the interstellar current. The presence of a traveler from elsewhere acts as a mirror held to that past. It hints that the early solar system was not self-contained, but an open workshop that both imported and exported material. The chemistry of the visitor, intricate but moderate, paints a second lesson. Variation in volatile ratios does not require exotic stories. It can arise from ordinary mixing in a disk where heat, shadow, and radial drift rearrange pebbles and ices before they gather into comets. The solar system's comets already speak in several dialects of carbon chains and oxygen lines. A newcomer who fits between the extremes encourages a view in which this star's nursery was typical in its patchwork. The implication reaches into models of Earth's water and organics. Delivery did not need to rely on a narrow class of carriers. A broad spectrum of small bodies with layered memories could have supplied ingredients for oceans and early chemistry, and the source catalogue likely included pieces once bound to other suns. The gentle shock at the frontier between coma and wind offers a lesson closer to present climate. The heliosphere is often studied at scales larger than any single comet, yet the boundary wrapped around a faint coma turns out to be a model of how the sun's breath negotiates with obstacles. By watching the ion tail kink and reconnect under gusts, science learns how plasma responds to magnetic draping and wave growth in conditions that shift from hour to hour. Those responses scale upward. They inform how the solar wind shapes the planetary magnetospheres that protect atmospheres and power auroras. A quiet comet teaches how a star's weather writes on small canvases, and the brushstrokes resemble those used on the larger ones. Rotation and torque in the visitor's nucleus suggest a third reflection. Small worlds carry clocks that can be nudged by the lightest of hands. Outgassing can break or spin up a body by fractions of a second per day. Over seasons, those fractions add up. In the solar system, where dormant comets can be roused by planetary tides or by subtle heat migrations, such torques may tune or destabilize spin states just before encounters, setting the stage for fragmentation or reshaping. Planetary defense relies on predicting paths and attitudes. Learning that torque histories can be reconstructed from light curves and then forecast forward sharpens the art of anticipating how a fragile body will aim jets and spread dust. The practical lesson is that monitoring matters. A patient eye can see the future written as a derivative in time. Dust speaks to the ground beneath major worlds. If the visitor's grains favor fluffy aggregates with organics on their surfaces, then accretion in the early solar system likely fed protoplanets with similar material. Fluffy grains do not shock or compress like glassy pebbles. They flatten, stick, and deliver heat and chemistry gently. Their presence in Comets today argues that the building blocks of planets included components that can survive interstellar radiation for ages and still act as carriers of complex carbon when warmed. In models of early Earth, this supports scenarios in which gentle drizzle from comets and small icy asteroids deposited not only water, but a variety of prebiotic fragments, seeded across epochs rather than delivered in rare catastrophic drops. The visitor's modest activity, at sizable distance from the Sun, offers a lesson about crusts. Icy surfaces acquire skins that can suppress outgassing, then yield along rare seams. Local comets show similar behavior, but they also have histories of many perihelion passages. A first-time passer from afar brings a cleaner experiment. If activity starts early and maintains a braided balance between carbon dioxide and water, then pores and fractures must provide deep pathways that remain functional, despite irradiation. Translated homeward, this suggests that some bodies in the solar system may retain interior volatiles accessible through natural conduits. The pattern has implications for attempts to sample ancient ices without melting them. It encourages instruments that sniff for gases at shadowed vents, rather than only at illuminated faces. The interstellar trajectory brings an architectural lesson about the Oort cloud. The cloud is often treated as a static halo. In truth, it is a port. Departures and arrivals occur on timescales that exceed any single lifetime, but statistics accumulate. A traveler from elsewhere raises the probability that the solar system inherits occasional guests and donates occasional natives. The exchange means that the chemical diversity of long-period comets around this star may include contributions from other nurseries, complicating efforts to read a single origin from a single sample. It also suggests that perturbations by passing stars and galactic tides routinely reconfigure the roster, keeping the periphery of the system lively. Observational craft learned a lesson with immediate use. The detection pipeline and the global network that followed the target confirmed that rare events can be pursued with a choreography that unites small telescopes and large ones, amateurs, and facilities in orbit. That choreography will serve the next faint messenger, but it also improves the daily practice of time-domain astronomy across all classes of small bodies. Techniques proven on a delicate coma, including rapid polarimetry, integral field mapping, and coordinated occultation campaigns, translate to local comets, to active asteroids, and to outbursting dwarf worlds. The improvement is not a side effect. It is the dividend of listening hard. A philosophical consequence hides inside instrumentation choices. The visitor cooperated with instruments that measured nuance rather than spectacle. Future priorities for solar system work can take heart from that. A moderate aperture with a flexible schedule and a disciplined pipeline can sometimes outrun a larger mirror with slow bureaucracy. Networks that trade nightly control for global coverage can answer questions that single sites cannot. The Sun's system is a moving theatre. Cameras that move with it, and software that sifts quickly, become as important as deeper wells of light. The spectrum of the visitor nudges models of prebiotic delivery toward diversity rather than toward a single preferred vector. Several families of organics, modest in strength but persistent, point to a steady supply rather than to rare stunts. If such chemistry is common among exports from many stars, then the early Earth likely bathed in a gentle rain of possibilities. The same logic applies to other young worlds under other suns. A lesson returns to the present. The solar system remains immersed in a medium that carries remnants from many workshops. Occasionally one crosses the inner lanes and whispers aloud. More often dust and neutral atoms drift through, too faint to notice. The faintness does not lessen the cumulative exchange. Interstellar traffic also tempers stories about uniqueness. The solar system is neither especially open nor especially closed. It is average enough to export a share of cold books to the library between stars and to borrow a few in return. Accepting that modesty reshapes expectations for rare events. An interstellar visitor is not a miracle. It is a statistical promise kept. The appropriate response is to prepare methods that turn rarity into measured routine. Once routine arrives, patterns emerge. Patterns become constraints. Constraints feed the models that describe how the sun grew its planets and how it cleaned the paths between them. Finally, the visitor places a subtle responsibility on the craft that studies comets at home. If exiles from other suns can carry balanced bouquets of volatiles and dust, then local comets that appear depleted or enriched may not tell the entire tale on first glance. Surfaces evolve. Crusts mature. Vents migrate. Distributed sources in the coma can counterfeit nucleus properties if not separated with care. The cross-check, provided by an interstellar sample, encourages a stricter discipline in interpreting local spectra and light curves. It reminds that the solar system's story is most clearly written when multiple instruments read it together, and when models are asked to predict not only flavor but timing, not only composition but rotation and torque. A small traveler, by saying little and saying it carefully, invites this star's household to read itself again. The lessons are not proclamations. They are adjustments in confidence and in method. Planetary systems remain open. Heliospheric weather speaks through small interactions. Torque writes with a fine pen. Crusts hold paths to deep reservoirs. The cloud at the edge is a port, not a mausoleum. Networks that value cadence are as powerful as single mirrors that value depth. Chemistry suggests gentle rain, not singular storms. With those notes absorbed, the solar system looks less like a solitary family and more like a participant in a quiet exchange that never stopped. Night reclaimed the domes, and the object dwindled to arithmetic. Pixels thinned into uncertainties. Ephemerides marched on, confident in geometry yet faint in light. In that retreat, the work did not fade. It clarified. Raw images settled into calibrated stacks. Spectra were trimmed of telluric scars, and reborn as lines that could be compared without excuse. Period solutions, once tentative, folded into tables, where each digit earned its place. The receding point in the sky had become a discipline, and the discipline began to speak about the shape of attention itself. Attention proved to be an instrument with parts that can be tuned. Cadence mattered as much as aperture. A small telescope that refused to miss a night revealed rhythms that a larger one could not, no matter how deep it reached. Patience formed a lens of its own. Weeks of nearly identical measurements, dull in isolation, conspired to carve significant trends out of noise. Collaboration turned bias into balance. One team's favored model was disarmed by another team's alternative, and the residue between them grew into fact. What faded on the sky brightened in method. The lesson did not need a spectacle to be beautiful. It needed the everyday bravery of consistency. As the traveler receded, the instruments that measured it were adjusted, repaired, and in some cases retired. Each carried a dent from the strain of being asked to work at the edges of their promise. Engineers learned which bearings hummed during long nights of non-sidereal tracking, which filters drifted under cold, which detectors revealed cosmetic blemishes only when pushed toward limits. Software wrote its own log of scars. Pipelines acquired patches that caught corner cases. Schedulers revised rules so that targets of opportunity could interrupt with less friction. The small cost of these changes bought time for the next faint approach, time measured in minutes that will matter. The archive filled. In one sense, it is only storage. In another, it is the mind of a craft. Light curves with uncertainties, spectra with notes on seeing, polarization angles with careful flags, radio lines with beam sizes and pointing errors, images labeled with every choice made during reduction. Future readers will need the texture of those notes more than they will need a single dramatic plot. In that texture lives the humility that keeps modelers honest. A number without its story can be misused. A number with its story teaches even when it disagrees with the next one on the page. Forecasts stepped forward to fill the quiet left by the vanishing point. Detection rates were revised. Sky coverage maps were redrawn. Surveys traded cadence for depth in certain months and reversed the trade in others. Occultation networks rehearsed with asteroids that offered quick practice. Narrowband imagers designed new filters, with band passes tied to fragile species that earlier nights had hinted at but not fully resolved. A small set of teams began to practice rapid coordination drills. A candidate appears. Within an hour, time is requested on 3 continents. Within a day, Spectra in the ultraviolet and millimeter bands join the photometry. Within a week, a coherent plan replaces improvisation. Drills are theatre until a faint signal turns them into necessity. The concept of meeting a traveller in space moved from dream to schedule. Small interceptors were sketched with tighter mass budgets and broader use cases. Propulsion plans put honest numbers next to hope. Shielding for dust was modelled against the size distributions drawn from the fading visitor's coma. Mass spectrometers were tuned on laboratory ices that cooked under ultraviolet light in sequences designed to mimic the slow noon of distance from any star. Guidance software learned to fly by the same stars that earlier telescopes had used as references. The romance of pursuit learned to count. Cultural weather shifted a little too. For a season, images of a faint fan and a soft tail shared pages with brighter things. The public ear bent to quieter fascinations. Teachers smuggled spectra into classrooms and invited students to think of light not as a photograph but as a coded letter. Amateur observers discovered that precise timekeeping and meticulous calibration can let a small instrument write in a large book. The story being told was not one of conquest. It was one of listening, and it suggested that listening can be a civic act. The receding path left behind a field of hypotheses pruned into shape. Some were discarded without regret. Others were held in reserve, labelled as not yet wrong in a narrow sense but not yet useful either. The ones that survived were those that made predictions, and then risked them under clear skies. That habit spread. It touched work on local comets, on active asteroids, on the slow weather of planetary rings. The presence of a distant messenger had reminded the household of smaller worlds that each problem should be made testable, each novelty given a clock and a coordinate. There was also a quiet shift in what counted as sufficient evidence. A single measurement bent at the edge of noise now carried less authority than a sequence of modest points that agreed with each other across methods. Preference moved away from isolated claims and toward ensembles. The physics had not changed. The style had matured. A community that expects more from its stories becomes a community that can be trusted with rarities. On clear nights, the sky did what it always does. It offered star fields crowded and star fields spare. Somewhere within them, other objects were on their way, indifferent to preparation and receptive to it. Curiosity learned to rest in readiness rather than in appetite alone. Readiness is a stack of routines that can be summoned at a glance, a web of colleagues who know whom to call first, a shelf of code that has been tested under stress, a budget that has a little room for surprise. Readiness has gratitude folded inside it. It assumes that rarity will visit again, and that the right response to rarity is to treat it as ordinary enough to have a checklist. The wake of the visitor could be followed for a time as dust thinned along its lane. Then even that sign dissolved into background. What remained was a question that refused to cool. It was not large. It sparkled with the restraint of embers. The question asked how many such messengers cross the dark while no one watches, how often they moor their gentle shock fronts in the solar wind and drift on without a single pixel to show for it. The answer will not arrive as a claim. It will arrive in the steady arithmetic of detections that finally become routine. Routine in this case will be a kind of wonder. A person standing under a dark sky needs no plot to feel this. The stars are more than points. They are a slow river. Small leaves ride it. Some belong to nearby trees. Some drift from distant shores. To notice a leaf is to learn something about the whole river. To measure it carefully is to learn how rivers choose their banks. In time, the measurements gather into a map, and the map changes how a household builds near water. In that analogy lives a promise. The next interstellar leaf will arrive. The next measuring stick will be ready. The next quiet boundary between winds will trace itself around a nucleus, and instruments will hear its whisper again. The wake will be gentle. The lesson will be sharp. The embers will glow a little brighter in the archive of attention. A wind comes thin and patient across a field where instruments sleep. It smells of frost and distant tides of air. It knows nothing of names, and it does not care whether a mirror is polished or a shutter clicks. It moves anyway, as everything that has room to move will do. Beyond the field, beyond the cities with their considerate lamps, beyond the curve of oceans that do not admit borders to the eye, the night keeps its ledger. Small bodies cross it. They are quiet as moths and old as ruins not yet built. Each carries an itinerary written by gravity and amended by heat and altered by encounters so slight that only instruments can tell where they pressed. In that ledger are blank lines that wait. The waiting is not stillness. It is a kind of slow music that asks for listeners who will not hurry it. Those listeners have learned the mathematics of humility. They do not ask the sky to be simple. They ask themselves to be clear. They string time across void and call the string a light curve. They split color and call the split a spectrum. They notice when a shadow brushes a star and call that gesture a size. They are apprentices to a language that does not forgive adjectives. The next visitor is already falling through distances too large to count without metaphor. It will arrive with an accent of its own. It will carry a crust of its own, a set of channels and seams that decide where breath appears. It will not perform. It will persist. Persistence is the true spectacle. The light it gives will be enough. The discipline it asks for will be the same gentle work that has always turned faintness into fact. Someone will listen. Someone will share. Someone will adjust a clock and name a file, and push a chair back from a console when the run completes. Beyond that, the night will remain as wide as ever and as available. Sweetness lies there, not in answers but in attention that does not tire, in embers that keep the room warm long after a visitor has gone.